Imagine looking at the universe and discovering that everything you can see, every star, every galaxy, every speck of light that has ever reached your telescope, accounts for only 5% of all the matter that exists, leaving 95% of reality composed of two invisible substances that we cannot directly observe, cannot touch, and cannot identify with any certainty whatsoever. This is the predicament of modern cosmology, where observations of how galaxies rotate and how galaxy clusters move through space reveal gravitational effects far too powerful to be explained by visible matter alone, suggesting that vast halos of unknown material surround every galaxy, holding them together through an invisible gravitational embrace. Scientists call this dark matter, yet the name represents an admission of profound ignorance rather than a description of understanding, because despite decades of sophisticated experiments and theoretical frameworks, we have no confirmed idea what dark matter actually is. The human mind naturally seeks to categorize and name things as a way of achieving psychological closure and a sense of comprehension. So we assigned a name to this mystery, and in doing so created an illusion that we were naming something we understood, when in reality we were simply labeling our collective bewilderment with a scientific phrase that sounds authoritative and complete. Physicists have proposed that dark matter might consist of weakly interacting massive particles, or perhaps primordial black holes, or exotic relics from the Big Bang itself. Yet each theory requires assumptions that seem increasingly desperate and speculative the more closely they are examined. Perhaps no question has haunted humanity more persistently than the simple yet devastating inquiry into how consciousness itself emerges from the physical matter of the brain, a phenomenon so intimately familiar to us that we experience it every waking moment, yet remains fundamentally mysterious and resistant to scientific explanation. We know that consciousness exists because we are conscious, because we experience the redness of red and the painfulness of pain, because we possess subjective inner lives that seem to exist in a realm entirely separate from the objective physical world that neuroscience can measure and study and map with increasing precision. Yet when neuroscientists examine the brain with all their sophisticated tools and techniques, when they observe neurons firing and neurotransmitters flooding synapses and electrical patterns cascading across neural networks, they cannot find the place where subjective experience is generated, cannot locate the mechanism that transforms mere physical processes into the felt quality of experience that philosophers call qualia. The hard problem of consciousness, as it has come to be known, represents perhaps the deepest explanatory gap in all of science, for we can describe what the brain does without ever explaining why that doing feels like something from the inside, why there is something it is like to see the color blue rather than nothing at all. Some scientists propose that consciousness might emerge from quantum processes in microtubules. Others suggest it arises from integrated information patterns. Still others argue that consciousness might be a fundamental feature of reality itself, rather than something produced by brains. Yet none of these theories have achieved anything approaching consensus, and each leaves us with profound unanswered questions about the very nature of subjective experience. In the late 1990s, astronomers made an observation that fundamentally contradicted everything we believed about the universe's fate, discovering that the expansion of space itself was not slowing down due to gravity, but rather accelerating at an ever-increasing rate, as though some invisible force was pushing everything apart with growing intensity, and this mysterious phenomenon accounts for approximately 68% of all the matter and energy in the observable universe. Yet we have no idea what it actually is or how it functions. The evidence comes from studying distant supernovae, those exploding stars whose light traveled billions of years to reach our telescopes, and when scientists measured how far away these explosions occurred based on their brightness, they discovered these ancient stars were farther away than they should have been if gravity alone governed cosmic expansion, suggesting that something had accelerated their recession throughout cosmic history. We call this unknown force dark energy, a name that essentially means we have labeled our ignorance, for it describes neither what dark energy is composed of nor what mechanism drives it, and we can only observe its effects on the largest scales imaginable, watching galaxies cluster and drift apart in ways that mathematics struggles to explain. The psychological mechanism of acceptance here operates quietly through institutional consensus and mathematical language, because physicists have developed sophisticated equations that incorporate dark energy as a cosmological constant, making its existence feel inevitable and scientifically grounded even though the underlying nature remains completely obscure. And students learn these equations in textbooks the same way previous generations learned about established forces, creating the impression that understanding the mathematics somehow equals understanding the phenomenon itself. Imagine standing at the edge of human understanding, where two of our most powerful descriptions of reality refuse to speak to one another. General relativity, Einstein's magnificent theory of gravity, describes the cosmos as a smooth fabric of spacetime that curves around massive objects, governing the motion of stars and galaxies and black holes with stunning precision. Quantum mechanics, our equally successful framework for the subatomic world, describes reality as fundamentally probabilistic and strange, where particles exist in superposition and observation itself changes outcomes. These two theories work brilliantly in isolation, yet they contradict each other fundamentally when applied to the same problem. At the heart of a black hole, where gravity becomes infinitely strong and quantum effects become unavoidable, both theories break down completely, producing infinities that physicists cannot reconcile. The deeper mystery is not merely that we lack a unified theory, but that despite decades of extraordinary intellectual effort from the brightest minds in theoretical physics, despite billions of dollars invested in research and countless peer-reviewed papers proposing solutions like string theory, loop quantum gravity, and asymptotic safety, we remain utterly unable to determine which framework, if either, is actually correct. We have normalized this fundamental schism in our understanding of reality, treating it as an acceptable gap in human knowledge, a problem for future generations, rather than confronting the possibility that our entire conceptual framework for describing nature might be incomplete in ways we cannot yet fathom. The mystery persists not because the mathematics is too difficult, but because reality itself might operate according to principles so alien to human intuition that we lack the very conceptual tools necessary to even formulate the right questions. Imagine standing at the absolute edge of understanding, where even the most fundamental questions collapse into silence. There's a puzzle so profound that it precedes all other mysteries, a question that philosophers, physicists, and theologians have circled for millennia without resolution. Why does anything exist at all rather than nothing? The universe, with its billions of galaxies and countless atoms forming matter and energy in elaborate patterns, could theoretically not exist. There is no logical law of physics that requires existence itself to be inevitable. In fact, the default state, the mathematically simpler option, would be absolute nothingness. No space, no time, no particles, no laws, no possibility of consciousness to observe any of it. Yet here we are, trapped in a reality of overwhelming complexity and presence. The question seems almost trivial when stated so simply, yet it remains unanswerable through any known framework of reason or scientific inquiry. Physics can explain how the universe evolved from its earliest moments, but it cannot explain why those earliest moments happened at all, why the initial conditions were set, or why existence was chosen over the infinite peace of non-being. Our minds attempt to rationalize this through creation myths, divine will, or quantum fluctuations, yet each explanation merely pushes the question one layer deeper. We have normalized this profound absence of understanding by relegating it to philosophy or spirituality rather than treating it as the cosmic absurdity it truly is. We conduct our lives as though the fact of existence requires no justification, as though being here is self-evident and needs no explanation. Yet each night when consciousness dims toward sleep, the question remains, a whisper in the darkness that no amount of scientific progress has ever truly answered. Among the deepest puzzles that physics has failed to resolve stands the question of why time flows in only one direction, a phenomenon so fundamental to our experience that we rarely pause to question it, yet so philosophically troubling that it reveals the limits of our understanding of reality itself. We observe with absolute certainty that time moves forward, that causes precede effects, that entropy increases and disorder spreads throughout closed systems. Yet when physicists examine the fundamental laws of nature at the most basic level, these equations reveal something profoundly strange. They work equally well in both directions, forward and backward in time, suggesting that the arrow of time should not exist at all, and yet it undeniably does. The second law of thermodynamics tells us that disorder increases over time, that heat flows from hot objects to cold ones, and never the reverse, that broken eggs never reassemble themselves. Yet this law is ultimately rooted in probability and statistics rather than fundamental physical law, a disturbing foundation for something so absolute in our lives. We possess no deeper explanation for why the universe chose to expand forward in time rather than backward, why our memories point toward the past and not the future, or why causality seems to flow in one direction despite having no obvious reason to do so based on the mathematical structure of reality itself. The psychological mechanism underlying our acceptance of this mystery involves a kind of normalized complacency, a willingness to treat time's direction as simply the way things are rather than as a profound violation of symmetry that demands explanation, as if accepting the brute fact of temporality allows us to avoid confronting the deeper question of why any direction should exist at all. When Stephen Hawking discovered in 1974 that black holes emit radiation and eventually evaporate, he inadvertently created one of the most profound paradoxes in modern physics, because according to quantum mechanics, information cannot simply disappear from the universe. Yet black holes appeared to violate this fundamental principle by destroying all data about the matter that fell into them, leaving behind only thermal radiation with no trace of what had entered. Imagine a library burning down completely while releasing only random heat into the air. Observers outside would have no way to reconstruct the contents of the books that were destroyed, and this is precisely what seemed to happen with black holes according to Hawking's calculations. The paradox emerges from a deep tension between two pillars of modern physics that should be complementary but seem irreconcilable in this context. General relativity predicts that black holes exist and will evaporate through quantum effects, while quantum mechanics insists that information is never truly lost, only transformed and scattered, meaning that theoretically every piece of information about every particle in the universe is preserved somewhere in the quantum state. Physicists have proposed numerous solutions over the decades, suggesting that information might be encoded in subtle correlations within the radiation, or perhaps stored in remnants left behind, or even preserved through connections to baby universes spawned from the black hole's interior. Yet none of these explanations has achieved consensus or complete mathematical consistency. The moment you begin observing a phenomenon in the quantum realm, the very act of measurement fundamentally alters what you're trying to measure, a principle so strange that it has haunted physics for over a century without resolution. When scientists attempt to determine the position of an electron, they must use light or other particles to detect it, and these detection methods necessarily impart energy to the electron, changing its momentum in the process, making it impossible to know both position and momentum simultaneously with perfect accuracy. This is not merely a limitation of our instruments or our current technology, but rather a boundary woven into the fabric of reality itself, where observation and existence become inseparably entangled in ways that defy classical intuition. The deeper mystery lies not in the mathematics, which physicists have mastered with impressive precision, but in the fundamental question of what observation actually means and why the universe should behave differently when something is watching compared to when nothing is watching at all. Some interpretations suggest that consciousness itself plays a role, that the act of a conscious observer looking at reality somehow collapses wave functions and forces quantum possibilities into singular outcomes, a notion so philosophically loaded that it has spawned entire schools of thought and generated controversy across multiple disciplines. Others propose that observation is simply interaction, that any measurement apparatus necessarily disturbs the system, yet this explanation fails to account for why the universe seems to have different rules depending on whether we look or not, as if reality itself is fundamentally aware of our attention. Consider the sheer scale of the universe as we understand it today, with hundreds of billions of galaxies, each containing hundreds of billions of stars, and a significant fraction of those stars orbiting planets that could theoretically harbor life. Given these almost incomprehensible numbers and the fact that life emerged on Earth relatively quickly in cosmic terms, the mathematical probability suggests that intelligent civilizations should be scattered throughout the cosmos like dust across an infinite floor. Yet when we turn our telescopes toward the heavens and listen with our most sensitive radio equipment for signs of extraterrestrial communication, we hear only silence, an overwhelming and perhaps disturbing silence that has puzzled scientists for decades. This contradiction between the statistical likelihood of alien life and the complete absence of any detectable evidence for it forms the essence of what physicist Enrico Fermi famously summarized in a single question: where is everybody? The question itself operates as a gateway to deeper uncertainties about the nature of technological advancement, the lifespan of civilizations, and whether intelligence itself might be far rarer than our optimistic calculations suggest. Perhaps intelligent life simply does not last long enough to develop interstellar communication, or perhaps the conditions required for consciousness to emerge are so extraordinarily specific and fragile that they represent a cosmic rarity rather than a common occurrence. We have normalized this silence by creating frameworks that explain it away: the Great Filter Hypothesis, the Rare Earth Theory, the Zoo Hypothesis, each offering a comfortable narrative that resolves the tension without addressing the fundamental unsettlingness of the paradox itself. In the beginning of our universe, roughly 13.8 billion years ago, the Big Bang created equal quantities of matter and antimatter, two fundamental substances that should have annihilated each other completely in a blinding flash of energy, leaving behind nothing but pure radiation and an utterly empty cosmos devoid of stars, planets, and the possibility of life itself. Yet somehow, inexplicably, we exist. Our world is made entirely of matter, not antimatter, and physicists have spent decades grappling with this profound asymmetry that defies every principle of symmetry we hold dear in fundamental physics. When matter and antimatter particles meet, they destroy each other in a process called annihilation, converting their mass entirely into energy according to Einstein's famous equation, and this should have been the universe's fate in its first fraction of a second. The mystery deepens when we consider that our most rigorous mathematical models, the ones that describe particles and forces with extraordinary precision, suggest that matter and antimatter should have been created in perfectly equal amounts during the violent expansion of the early universe. Something must have broken this symmetry, tipping the scales infinitesimally in matter's favor, allowing a tiny excess of ordinary matter to survive the mutual destruction that claimed nearly all the antimatter in existence. Scientists have proposed various mechanisms to explain this imbalance, including subtle differences in how matter and antimatter interact with fundamental forces, yet none of these explanations has been conclusively proven or widely accepted. Consider the moment you decide to reach for a glass of water, or choose what to eat for dinner, or decide to change your career entirely. The sensation is unmistakable and profound. You feel as though you are the author of that choice, that some essential you exists within your consciousness and generates these decisions through deliberate consideration and intent. Yet neuroscience has begun to reveal something deeply unsettling beneath this intuitive certainty. Brain imaging studies show that neural activity associated with a decision appears to occur in measurable patterns several seconds before you become consciously aware that you have made a choice, suggesting that your brain has already committed to an action before your subjective experience of deciding has even begun. The decision, it seems, emerges from electrochemical processes occurring in regions you cannot access through introspection or willful intervention. If your brain determines your actions before consciousness registers the choice, where exactly does free will reside? The mechanism underlying this mystery involves the architecture of human awareness itself. Your conscious mind experiences itself as unified, continuous, and in control, yet neuroscientists describe the brain as a collection of competing systems, automatic processes, and subconscious mechanisms that operate largely outside your awareness. Emotions, instincts, learned behaviors, and genetic predispositions all shape the decisions you believe you are making freely, yet you cannot choose to change these underlying drivers through sheer willpower alone. Every choice appears to flow from prior causes: your past experiences, your neurochemistry, your environment, your genetics, none of which you selected. The philosophical problem becomes evident, yet somehow the illusion persists with remarkable resilience. Imagine standing at the edge of possibility itself, where physicists have begun to seriously propose that our universe is not alone, but rather one bubble among infinite others, each with different laws of physics, different constants, and different versions of reality unfolding in parallel to our own. The multiverse theory emerges not from science fiction or philosophy, but from the careful mathematics of quantum mechanics and cosmological inflation, where the equations themselves seem to demand the existence of multiple universes branching endlessly from quantum events and cosmic expansion. When a quantum particle exists in a superposition of states until observed, some interpretations suggest that all possible outcomes actually occur, each in its own separate branch of reality, meaning that every decision you have ever made spawns an alternate timeline where you made a different choice. creating an ever-expanding tree of parallel universes populated by alternate versions of yourself. The psychological mechanism behind our fascination with the multiverse lies in our deep discomfort with finality and uniqueness. The idea that infinite versions of ourselves exist out there, making different choices and living different lives, somehow makes our own existence feel simultaneously more special and less consequential, as if our failures and successes are balanced by infinite alternate outcomes. Yet despite the profound logical implications of this theory, that nothing we do truly matters because all possibilities are realized somewhere, we continue through life as though our choices are singular and irreversible, and we have normalized the notion that somewhere, in some distant mathematical space beyond observation or reach, countless versions of reality are playing out without ever disturbing our sense of agency or responsibility in this one. Quantum entanglement stands as one of the most perplexing phenomena in physics, where two particles become correlated in such a way that measuring a property of one particle instantaneously influences the state of the other, regardless of the distance separating them, even if they exist on opposite ends of the observable universe. When particles are entangled, their quantum states are fundamentally linked, and the moment you observe one particle's spin or polarization, its paired partner seems to know what happened and adjusts its own properties accordingly, appearing to communicate faster than light itself could travel between them. Einstein famously called this spooky action at a distance because it violates our intuitive understanding of locality and causality, principles that have anchored physics since Newton's time. The mechanism behind how this instantaneous correlation occurs remains genuinely unknown, despite decades of experimental verification that entanglement absolutely exists and functions exactly as predicted by quantum mechanics. Physicists have wrestled with various interpretations. Perhaps hidden variables we haven't discovered yet contain the information needed to explain the correlation, or perhaps reality is fundamentally non-local and particles exist in states of superposition until observation forces them into definite values. Yet despite having no satisfactory mechanism that explains the how of entanglement, we've normalized it entirely within the scientific community, accepting it as fundamental behavior rather than a phenomenon demanding explanation, much like our ancestors accepted gravity without understanding its mechanism. Deep within the geological record of Earth, somewhere between 4 and 3.8 billion years ago, something extraordinary occurred that fundamentally altered the nature of this planet, yet we cannot definitively say what that something was. Life emerged from non-living matter through processes we have yet to fully comprehend or successfully recreate in laboratory conditions, and this absence of understanding creates a peculiar cognitive dissonance within modern science. We know that life exists, we can observe its mechanisms at the molecular level, we understand how it reproduces and evolves and adapts, and yet the precise moment and method of its genesis remains obscured by time and the constraints of our investigative tools. The leading hypothesis, known as abiogenesis, proposes that simple organic molecules assembled themselves through chemical processes driven by energy sources such as lightning, ultraviolet radiation, or hydrothermal vents, gradually becoming more complex until they achieved self-replication and metabolism. However, each attempt to demonstrate this process in controlled environments reveals new complications and improbabilities that seem to multiply rather than diminish. The probability calculations suggest that random chemical assembly could not produce the necessary complexity within any reasonable timeframe, and yet life demonstrably did originate through some naturalistic mechanism because the alternative explanations offer even fewer testable propositions. We have normalized this mystery by dividing it into smaller problems, each theoretically solvable, yet the holistic question of how consciousness and biological order emerged from chaos and entropy remains fundamentally unanswered. Consider the profound and unsettling reality that within the human body exists a mechanism so powerful that it can reduce pain, lower blood pressure, accelerate healing, and even alleviate symptoms of serious illnesses. Yet this mechanism requires only the patient's belief that they are receiving treatment rather than any actual pharmacological intervention. Patients who receive inert sugar pills or saline injections while being told they are receiving powerful medications often experience genuine physiological improvements that rival the effects of legitimate treatments, and this phenomenon persists across cultures, demographics, and medical conditions with remarkable consistency. The placebo effect has been documented in cases of arthritis pain diminishing after fake surgery, anxiety symptoms subsiding after administration of inactive compounds, Parkinson's disease motor symptoms improving measurably after injection of salt water presented as revolutionary medication, and even post-operative wound healing accelerating when patients believe their care is superior to what it actually is. Yet the mechanism remains profoundly mysterious because the brain somehow translates expectation and belief into measurable changes in immune function, neurotransmitter production, inflammation markers, and cellular repair processes. Neuroscience has identified that believing in treatment activates specific neural pathways and triggers the release of endogenous opioids and dopamine, and brain imaging shows genuine activation of pain processing regions when placebos are administered. Yet how the conscious act of believing neurologically cascades into actual bodily healing has never been fully explained. In the late 2008, astronomers studying the cosmic microwave background radiation, that ancient light left over from the Big Bang itself, discovered something deeply troubling hidden within the data. Massive galaxy clusters appeared to be moving in a coordinated direction toward a specific region of space, all flowing together as though pulled by some invisible gravitational force located beyond the observable universe. This phenomenon became known as dark flow, a mysterious acceleration pattern that defies our current understanding of cosmic structure and motion, suggesting that something vast and gravitationally powerful exists in the direction of the constellation Centaurus, pulling matter toward it from across incomprehensible distances. The mechanism behind this observation involves the analysis of the kinetic Sunyaev-Zeldovich effect, a subtle temperature shift in the microwave background created when light passes through moving clusters of hot gas. And when researchers examined this data more carefully, they found that clusters separated by billions of light years all seem to share a common velocity component. A unified drift that should not exist according to our models of a universe that appears roughly uniform in all directions. This discovery sparked intense theoretical debate because the very existence of such a coordinated flow challenges the cosmological principle itself, the foundational assumption that the universe is homogeneous and isotropic when viewed on the largest scales, and it raises the possibility that we live in a portion of a much larger cosmos, a multiverse perhaps, where our observable universe occupies only an infinitesimal fraction of a greater whole. In quantum mechanics, there exists a phenomenon so fundamentally perplexing that it has divided physicists into competing philosophical camps for nearly a century, and this phenomenon is called wave function collapse, a concept that suggests reality itself does not exist in a definite state until the moment we choose to observe it. Before observation, a quantum particle exists in what is known as a superposition, a mathematical description of all possible states simultaneously, existing everywhere and nowhere at once, in a kind of probabilistic fog that defies our intuitive understanding of how the physical world actually works. Yet the instant a measurement is made, this ethereal superposition instantaneously collapses into a single definite outcome, as though the universe itself is making a choice based on whether we are watching. The psychological mechanism underlying our acceptance of this strange reality involves a gradual surrender to mathematical formalism over sensory experience. We have been trained to trust the equations that predict outcomes with extraordinary accuracy, even when those equations describe something that seems to violate basic logic and causality. We learn to accept that observation somehow causes physical change, that the act of measurement fundamentally alters what is being measured, and that there is no objective reality independent of our conscious interaction with it. What persists as truly mysterious is not merely the mechanism itself, but rather that we have constructed an entire framework of modern physics upon this conceptual foundation, without ever fully resolving what constitutes an observation, whether consciousness plays a role, or whether collapse is even real or merely an artifact of our mathematical tools. Imagine the universe at the very end of time, when all stars have burned out, all black holes have evaporated through Hawking radiation, and only the vast emptiness of space remains, stretching infinitely in every direction with a temperature approaching absolute zero. In this incomprehensibly distant future, the laws of thermodynamics and quantum mechanics suggest something deeply unsettling could still occur. Through purely random fluctuations in the quantum foam of spacetime itself, The particles and energy scattered throughout the void could spontaneously reassemble into conscious entities. These theoretical entities are called Boltzmann brains, named after the 19th century physicist Ludwig Boltzmann, who first contemplated this peculiar problem. A Boltzmann brain would be a fully functional conscious mind that emerges from absolute nothingness, complete with memories, thoughts, and self-awareness, existing for perhaps only a microsecond before dissolving back into chaos. The mechanism behind this lies in the mathematics of probability and entropy. If you wait long enough in a sufficiently large universe, any configuration of matter and energy, no matter how improbable, becomes not just possible but inevitable. The universe has nearly infinite time and infinite space to work with, so eventually, through sheer statistical chance, the atoms and particles constituting a brain, with all its neural complexity and electrochemical processes, would randomly coalesce. What makes this problem so profoundly troubling is that it seems to suggest there would be far more Boltzmann brains appearing spontaneously at the end of time than conscious beings like ourselves that evolved naturally through billions of years of biological processes. This creates an absurd logical paradox. If random fluctuations are more common than natural evolution, should we expect ourselves to be Boltzmann brains rather than normally evolved consciousness? Consider the possibility that everything you perceive, every sensation you experience, every memory you hold, and every moment you believe you have lived might be nothing more than data rendered within an elaborate computational system designed by an intelligence operating at a level of reality above your own. The simulation hypothesis suggests that our universe, with all its physical laws, quantum mechanics, relativity, and the emergent complexity of consciousness itself, could be a deliberately constructed environment no different in principle from a video game or virtual reality program, except infinitely more sophisticated and convincing. The intriguing aspect of this concept is that it is not merely philosophical speculation, but emerges from serious consideration by physicists, philosophers, and technologists who note that as computing power advances exponentially, the possibility of simulating entire universes becomes less absurd and more statistically probable when one considers the sheer scale of potential civilizations across infinite time. The psychological mechanism driving engagement with this idea stems from our deep human need to explain existence through frameworks we understand, and our current era of computational technology provides a metaphorical language for contemplating reality itself. We find the hypothesis compelling because it mirrors our own creative capabilities, projecting them onto a hypothetical higher dimension where some advanced consciousness might do unto us what we do unto our digital creations. Yet the simulation hypothesis persists as a serious intellectual consideration despite being fundamentally unfalsifiable and potentially meaningless, because it operates within the same framework as all observation itself, making it impossible to gather evidence that would distinguish simulated reality from authentic reality. In the vast cosmic accounting ledger that astronomers and physicists maintain, there exists a profound discrepancy that has persisted for decades without resolution, a gap so significant that it challenges our fundamental understanding of how the universe is actually composed. When scientists peer outward into the cosmos and observe the radiation signatures, gravitational effects, and light patterns emanating from distant galaxies and galactic clusters, they can calculate with reasonable precision how much ordinary matter, or baryonic matter as physicists call it, should exist throughout the universe based on our knowledge of the Big Bang and the distribution of elements we observe in stars and galaxies. Yet when they perform these calculations and sum up all the baryons they can actually detect through telescopes, spectroscopy, and other observational tools, they find themselves short by approximately 30 to 40% of the amount that cosmological models predict should be there. This shortfall, this missing inventory of cosmic material, has become known as the missing baryon problem, and it represents one of the most puzzling gaps in our inventory of the observable universe. The psychological mechanism underlying our continued puzzlement with this mystery involves a fundamental assumption we make about the universe's transparency to our instruments and senses. We inherently believe that what we can observe represents the totality of what exists, or at least that the vast majority of something as fundamental as ordinary matter should be detectable through the sophisticated instruments we have developed across multiple wavelengths of electromagnetic radiation. On August 15, 1977, a radio astronomer named Jerry Amon was sitting at the Big Ear Radio Observatory in Delaware, Ohio, monitoring frequencies for signs of extraterrestrial intelligence, when he noticed something extraordinary on the data printout before him. A signal so unusual and so powerful that he circled it in red pen and wrote the word "wow" beside it, a reaction that would define one of astronomy's most persistent mysteries for decades to come. The signal lasted for exactly 72 seconds, arriving on the frequency of 1420 MHz, which is the frequency at which hydrogen naturally emits radiation and is therefore considered the most likely frequency an advanced civilization would use to broadcast messages into the cosmos. And the strength of this signal was so concentrated and so intense that it appeared to come from a very specific location in the sky, near the star group Chi Sagittarii. What made the signal truly remarkable was that it matched the expected signature of an intelligent extraterrestrial transmission far more closely than any natural astronomical phenomenon ever recorded. Yet when astronomers attempted to locate it again in the following nights and weeks and months, the signal never returned, as if it had been a one-time occurrence or a transmission deliberately limited to a single brief moment. The psychological impact of the WOW signal on the scientific community cannot be overstated, because it represented the tantalizing possibility that we had finally detected proof of intelligent life beyond Earth, a moment that should have fundamentally changed our understanding of our place in the universe. Yet the signal's refusal to repeat created a persistent state of uncertainty and doubt that prevented any definitive conclusions from ever being reached. Imagine standing near a window during a thunderstorm when a luminous sphere, the size of a grapefruit, suddenly materializes in the air before you, glowing with an eerie blue or orange radiance, hovering silently for several seconds before vanishing without a trace or exploding with a peculiar hiss, leaving behind only the faint smell of sulfur and the absolute certainty that you have witnessed something that should not exist according to conventional physics. Ball lightning represents one of the most persistent yet thoroughly elusive phenomena in atmospheric science, a manifestation so rare and unpredictable that the vast majority of scientists have never observed one directly, yet thousands of credible eyewitness accounts spanning centuries across virtually every culture and continent describe nearly identical experiences with remarkable consistency. The phenomenon defies our standard understanding of electrical discharge, because while regular lightning follows plasma pathways and dissipates almost instantaneously, ball lightning appears to maintain coherence and structure, traveling slowly through the air, sometimes passing through solid objects like windows without breaking glass, and displaying an inexplicable resistance to the laws of thermodynamics and electromagnetic theory that should govern its behavior. Scientists have proposed numerous competing hypotheses ranging from plasmoid theories involving self-confining magnetic fields to silicon vaporization models, from exotic matter proposals to suggestions involving exotic molecules, yet none have achieved sufficient explanatory power to dominate the field, leaving researchers perpetually caught between the certainty that ball lightning exists based on eyewitness testimony and the impossibility that it should exist based on established physics. When you sit in an airplane and it suddenly drops through an air pocket, sending your heart into your throat and causing coffee to spill across the armrest, you are experiencing one of the most profound unsolved problems in physics, yet most people treat it as merely an inconvenience. Turbulence is the chaotic, unpredictable motion of fluids and gases, and despite centuries of scientific advancement and our ability to split atoms and send rovers to Mars, we still cannot mathematically predict or fully understand how turbulence forms, evolves, or dissipates in real time. The Navier-Stokes equations, developed in the 1800s to describe fluid motion, work beautifully for laminar flow, where fluids move in smooth, orderly layers, but the moment a fluid transitions into turbulent chaos, the equations become so complex that solving them exactly is considered one of the $7 million Millennium Prize problems. What happens in turbulence is that energy cascades from large swirling eddies down through progressively smaller and smaller vortices until it finally dissipates as heat at the molecular scale, a process called the energy cascade that we can observe but cannot predict with precision. The psychological mechanism that allows us to normalize this gap in our understanding is compartmentalization. We have learned to accept turbulence as something we engineer around rather than something we must fully comprehend, and we rely on empirical models, computer simulations, and statistical approximations that work well enough for practical purposes, even though they are fundamentally incomplete descriptions of physical reality. Engineers use Reynolds-averaged models and large eddy simulations that essentially average out the chaotic details rather than solving the true underlying equations. which is like describing a symphony by only knowing its average loudness rather than understanding each individual note. Deep within the Earth's outer core, swirling currents of molten iron and nickel generate the magnetic field that has protected our planet for billions of years, and yet this invisible shield is far from permanent or predictable. Throughout Earth's history, the magnetic poles have reversed their positions countless times, with the north magnetic pole becoming south and the south becoming north, a phenomenon that occurs irregularly over timescales ranging from hundreds of thousands to millions of years. Scientists have discovered evidence of these reversals preserved in volcanic rocks and seafloor sediments, where iron particles became magnetically locked in place during the moment of formation, creating a permanent record of the planet's magnetic orientation at that time. What remains deeply perplexing is that these reversals appear to follow no discernible pattern or schedule, arriving without warning, sometimes separated by stable periods lasting nearly 1 million years and other times occurring with startling frequency. The mechanism itself involves the chaotic, turbulent behavior of Earth's liquid outer core, where complex fluid dynamics and electromagnetic interactions generate the planetary magnetic field through a process scientists call the geodynamo. Yet despite decades of sophisticated computer modeling and mathematical analysis, researchers cannot predict when the next reversal will occur or why reversals happen at all. During the transition periods, which can last anywhere from 1,000 to 10,000 years, the magnetic field weakens dramatically and becomes highly irregular, potentially exposing the planet's surface to increased solar radiation and cosmic rays. Deep in the cosmos, telescopes occasionally detect something that should not exist according to our understanding of the universe. Brief, intense pulses of radio waves that arrive from across the vast distances of space, lasting only milliseconds, releasing energy equivalent to what our sun produces in entire days, and then vanishing without explanation or warning. These phenomena are called fast radio bursts, or FRBs, and they represent one of the most perplexing mysteries in modern astronomy because we simply do not know what generates them. When astronomers first detected these signals in 2007, they assumed contamination or equipment malfunction, yet repeated observations from multiple independent observatories across different continents confirmed the signals were genuine cosmic events. The bursts arrive with no apparent pattern, no detectable precursor, and no obvious mechanism that could produce such concentrated energy in such minimal time. Some bursts appear to repeat from the same location in space, while others seem utterly random and singular, establishing a fundamental inconsistency that prevents any unified theory. We have proposed countless explanations, merging neutron stars, magnetic field catastrophes, exotic matter collisions, even speculative suggestions involving advanced civilizations, yet none adequately account for all observed characteristics. The psychological mechanism driving our obsession with this mystery stems from our deep need to understand the universe as fundamentally comprehensible, governed by laws we can discover and apply. When phenomena like fast radio bursts resist categorization, they destabilize our confidence in that understanding. We have normalized this uncertainty through patient observation and theoretical frameworks, yet the basic question remains unanswered. What cosmic engine powers these incomprehensible bursts that pierce through billions of light years to reach our listening ears? For decades, physicists operated under a unified understanding of one of nature's most fundamental particles, the proton, measured with extraordinary precision through countless experiments conducted in laboratories across the world. The proton's radius was established at approximately 0.875 femtometers, a measurement so firmly embedded in our scientific understanding that it appeared in textbooks and formed the foundation for calculations in quantum mechanics and atomic physics. However, in 2010, a team of researchers examining muonic hydrogen, which is a hydrogen atom where the electron has been replaced by a much heavier particle called a muon, discovered something profoundly troubling and completely unexpected. When they measured the proton's size using this alternative method, they found it to be significantly smaller than previously thought, roughly 5% smaller, a discrepancy that should have been impossible given how thoroughly the proton had been studied. This finding triggered what scientists call the proton radius puzzle, a genuine crisis in fundamental physics that forced researchers to question either their most reliable experimental techniques or their most basic understanding of how particles behave. The psychological weight of this contradiction stems from our deep need for consistency in nature's rules, the expectation that measuring the same object through different methods should yield the same result. And yet multiple independent experiments using muonic hydrogen consistently produced the smaller measurement. Years of subsequent research have only deepened the mystery rather than resolved it, with some measurements supporting the traditional value while others confirm the smaller size, creating a paradox where reality itself seems uncertain depending on how you choose to look at it. Every single day, millions of people undergo surgical procedures while their consciousness is deliberately erased by chemical compounds. Yet the fundamental mechanism by which anesthesia actually works remains one of modern medicine's most profound mysteries. We can induce unconsciousness with remarkable precision. We can keep patients alive while they experience nothing. We can wake them up afterward, and yet when pressed to explain the actual biological process occurring in the brain during anesthesia, scientists must admit that despite decades of intensive research and billions of dollars invested in pharmaceutical development, we genuinely do not understand how these drugs accomplish this feat at a molecular level. Anesthetic agents like propofol, sevoflurane, and nitrous oxide have been used successfully for generations, and their clinical effects are completely predictable and reproducible, yet the chain of causation from molecular interaction to complete unconsciousness remains stubbornly obscure. Multiple competing theories attempt to explain the phenomenon, from disruptions in neural signaling to alterations in cell membrane properties to effects on specific neurotransmitter systems. But none of these explanations fully account for how consciousness itself is suppressed or how the brain transitions between awareness and complete insensibility. We have built an entire medical system around something we do not actually understand, using it to perform some of humanity's most delicate and crucial interventions while operating on a mechanism that remains fundamentally mysterious to us. Throughout Earth's history spanning billions of years, life has experienced 5 major extinction events, where the majority of species on the planet vanished within relatively brief geological timeframes, and scientists have long puzzled over why these catastrophic die-offs occur with what appears to be a measurable periodicity, suggesting some underlying rhythm or cycle to the planet's capacity to sustain biodiversity. The evidence is unmistakable in the fossil record, where entire families of organisms simply cease to exist, replaced by entirely new forms of life that evolved to fill the vacant ecological niches. Yet the timing of these events appears to follow patterns that defy easy explanation, with some researchers proposing intervals of approximately 27 to 30 million years between major extinction pulses, a regularity that seems far too precise to be coincidental. The most famous of these events was the Cretaceous-Paleogene extinction that eliminated the dinosaurs, but equally dramatic extinctions preceded and followed it, each one reshaping the fundamental composition of life on Earth in ways that took millions of years to recover from. Scientists have proposed numerous mechanisms for why these cycles might occur, including asteroid impacts, volcanic supereruptions, oceanic anoxia, rapid climate change, and even the possibility that our solar system passes through denser regions of the galaxy where comet showers become more frequent. Yet no single explanation adequately accounts for all extinction events or predicts their timing with certainty. Every moment you experience moves inexorably forward into what we call the future, yet the fundamental laws of physics governing our universe contain no inherent preference for forward motion over backward motion, a paradox that has puzzled physicists and philosophers for generations and remains one of the deepest unsolved mysteries of reality itself. When you observe the world around you, you witness a clear directional flow. Coffee cools but never spontaneously heats, broken eggs never reassemble themselves, memories form in one direction through time but never backward, and entropy in isolated systems perpetually increases rather than decreases. Yet when physicists write down the equations describing how particles interact at the quantum level or how celestial bodies move through space, these equations work equally well whether time flows forward or backward, suggesting that the universe at its most fundamental level holds no inherent preference for one temporal direction over the other, a phenomenon known as time symmetry or temporal reversibility. The psychological mechanism underlying our perception of time's arrow stems from our direct sensory experience of entropy increase and the fundamental thermodynamic principle that disorder naturally grows, while order requires constant energy input to maintain. and our brains have evolved to perceive this entropic gradient as the forward direction of time. We have normalized this profound asymmetry by treating it as so obvious that we rarely question why the universe should have this property, yet thermodynamic arrow of time and the psychological arrow of time and the cosmological arrow of time do not always align perfectly, creating logical inconsistencies about what time fundamentally is. Imagine constructing a theoretical model of the entire universe, one where you calculate how much energy should exist in the vacuum of empty space itself, that strange quantum foam that physicists believe permeates every corner of reality, and then imagine that your calculations produce a number so absurdly large, so monumentally incompatible with what we actually observe in the cosmos, that the discrepancy reaches upward of 120 orders of magnitude. A gap so profound that it makes comparing a single grain of sand to the entire observable universe seem like a trivial rounding error. This is the cosmological constant problem, one of the most humbling failures in the history of theoretical physics, a crisis that sits at the intersection of quantum mechanics and general relativity and refuses to be resolved by conventional reasoning. When physicists calculate the energy density that should exist in the quantum vacuum using quantum field theory, they arrive at predictions that suggest the universe should have expanded so catastrophically in the moments after the Big Bang that no galaxies, stars, or atoms would have ever formed. Yet we exist. We observe stable structures across billions of light years, and this contradiction persists as a quiet, almost embarrassing silence in the field. The psychological mechanism underlying our acceptance of this problem involves a peculiar kind of intellectual resignation, where physicists have largely moved past demanding a fundamental explanation and instead have simply incorporated an observational constant into their equations, treating the vacuum energy as a placeholder rather than something that should be derived from first principles, effectively sweeping an impossibly large inconsistency under an increasingly heavy theoretical rug. In 1989, two electrochemists named Martin Fleischmann and Stanley Pons announced to the world that they had achieved nuclear fusion at room temperature inside a simple tabletop apparatus, a claim that would have revolutionized energy production forever if true. Yet the scientific establishment largely rejected their findings despite the profound implications such a discovery would carry for civilization. What made this moment particularly fascinating was not merely the claim itself, but rather the psychology of how the scientific community responded to it, for cold fusion represented something deeply threatening to the established order of nuclear physics and the massive infrastructure of hot fusion research that had consumed billions of dollars and decades of effort without producing commercially viable energy. The mechanism behind the persistence of cold fusion as a possibility in the minds of some researchers and amateur scientists involves a curious human tendency to hold onto revolutionary ideas even when mainstream consensus dismisses them, because such ideas offer a kind of psychological redemption, a narrative in which a simple breakthrough could overturn everything we thought we knew and solve humanity's energy crisis in one elegant stroke. Furthermore, there exists a subtle but powerful cognitive pattern wherein the very fact that something was rejected by authorities becomes its own form of evidence to those inclined toward alternative thinking, transforming skepticism into an almost religious conviction that the truth was suppressed rather than disproven. Every year, billions of animals undertake journeys of staggering distance and precision, traveling across continents and oceans to reach destinations they have never seen before, guided by mechanisms so sophisticated that our greatest technological achievements struggle to replicate them. Arctic terns migrate nearly 44,000 miles annually, crossing from pole to pole with accuracy measured in mere yards, while monarch butterflies navigate across North America despite weighing less than a gram and possessing brains the size of sesame seeds. Yet somehow their descendants know the exact route their parents took generations before. Sea turtles released on beaches thousands of miles from their birthplace decades later return to those same beaches with haunting precision, and salmon swim upstream through rivers they have not encountered since they were tiny juveniles, somehow remembering chemical signatures and magnetic fields to navigate through murky water where vision becomes useless. The mechanisms at work appear to involve multiple overlapping systems: magnetoreception through iron oxide crystals or quantum entanglement in bird eyes, olfactory mapping through smell, polarization patterns of light, celestial navigation through stellar and solar positioning, and perhaps most mysteriously, some form of inherited biological map encoded directly into their genetic material that allows creatures to navigate to places they have never been. Yet despite decades of research involving satellite tracking, laboratory experiments, and genetic analysis, we cannot fully explain how these systems work together or how the brain integrates these signals into coherent navigation. Nor can we understand how information could possibly be inherited across generations in a form precise enough to guide migration across thousands of miles. Every second within your body, thousands of proteins are being synthesized from chains of amino acids, and the way these chains fold into three-dimensional structures determines whether they function correctly or fail catastrophically. Yet despite decades of computational power and scientific advancement, predicting exactly how a protein will fold remains one of the most computationally expensive and intellectually humbling challenges in modern biology. A protein begins as a linear sequence of amino acids, a simple string of building blocks that should theoretically fold into its functional shape based on nothing more than the laws of chemistry and physics. And yet the number of possible configurations a protein chain can assume is so astronomically large that even the most powerful supercomputers cannot calculate the correct fold through brute force methods. A problem known as Levinthal's paradox that essentially describes the impossible mathematics of shape prediction. The paradox reveals a fundamental gap between what we know must be true about protein chemistry and what we can actually compute, because if every possible fold configuration took even a nanosecond to evaluate, it would require longer than the age of the universe to find the correct one. And yet proteins fold spontaneously in milliseconds within living cells, suggesting that nature has discovered some elegant shortcut that our current understanding simply cannot replicate or even fully comprehend. Roughly 540 million years ago, during a geological period known as the Cambrian, the fossil record reveals something that continues to perplex paleontologists and evolutionary biologists to this day. A sudden and dramatic diversification of complex animal life forms that appear in the geological layers with startling abruptness, as though someone had flipped a switch in the history of biology itself. Before this period, the fossil record shows predominantly simple organisms, soft-bodied creatures and microbial life, yet within a relatively narrow window of geological time, perhaps spanning only tens of millions of years. Virtually every major animal phylum that exists today makes its first appearance in the fossil record, fully formed and remarkably distinct from one another. This phenomenon, called the Cambrian explosion, presents a profound puzzle because classical evolutionary theory suggests that such dramatic transformations should occur gradually over vastly longer periods, leaving behind abundant transitional forms and intermediate species as evidence of slow, methodical change. Yet the fossil evidence seems to contradict this expectation with a sudden burst of innovation that cannot be easily explained by conventional models. Scientists have proposed numerous mechanisms to account for this mysterious acceleration. Perhaps oxygen levels in the oceans rose sufficiently to support larger, more metabolically active creatures. Perhaps predation suddenly became an evolutionary pressure, driving rapid diversification as prey species evolved elaborate defenses and body plans. Perhaps genetic regulatory mutations unlocked new developmental possibilities that allowed organisms to experiment with radically different body structures. Perhaps environmental changes like shifting ocean chemistry or continental movements created ecological niches that could be rapidly filled. Beyond the orbit of Neptune lies a region of icy bodies and frozen debris known as the Kuiper Belt, a vast cosmic neighborhood that astronomers have been studying with increasing intensity over the past few decades. And yet within this region exists a phenomenon so peculiar that it continues to perplex researchers and challenge our fundamental understanding of how planetary systems form and evolve. The Kuiper Cliff is an abrupt and sharply defined edge to the distribution of objects in the Kuiper Belt, where the density of icy bodies drops dramatically beyond a certain distance from the Sun, creating what appears to be a literal boundary or wall in space, where objects simply become far fewer and farther between. This cliff is not gradual as one might expect from natural processes, but rather remarkably sudden, suggesting that something catastrophic or deliberately organized occurred in the early solar system to create this stark demarcation. Yet astronomers have struggled for years to develop a satisfactory explanation for why this boundary exists at all or what mechanism could have created such a clean and definitive edge. The prevailing theories suggest that gravitational interactions with Neptune during its formation and migration through the solar system might have scattered or removed objects beyond a certain threshold, or that the solar nebula from which all planets formed simply dissipated at this particular distance. But none of these explanations fully account for the sharpness and regularity of the cliff itself. Imagine looking at your hands, mirror images of each other, yet fundamentally different in their asymmetry. Now imagine that every single molecule in your body, in every living organism on Earth, demonstrates this same one-sided preference, a phenomenon called homochirality. The mystery lies not in the existence of this chirality itself, but in why life exclusively chose one direction over the other. When amino acids form, the chemistry of the universe produces them in equal measures of left-handed and right-handed forms, a perfectly balanced distribution that should theoretically persist in any emerging biological system. Yet somewhere in the primordial chemistry of early Earth, approximately 4 billion years ago, life made an irreversible choice, selecting only left-handed amino acids to build proteins, while simultaneously embracing right-handed sugars for its genetic material. The mechanisms we understand suggest this decision could have gone either way with equal probability, that a parallel universe with opposite chirality should exist with the same evolutionary success we observe. What our theories struggle to explain is the initial amplification event, the moment when a random molecular bias became so pronounced that it could drive all subsequent chemistry in one direction. Some scientists propose that circularly polarized light from distant stars could have preferentially destroyed one chiral form over another, while others suggest that certain clay minerals might have catalyzed reactions favoring one-handedness. Yet none of these hypotheses fully accounts for the universal adoption and maintenance of this pattern across all life. We have normalized this asymmetry so completely that we rarely ask why it exists at all, accepting it as simply the way life happens to work rather than recognizing it as one of the most improbable selections the universe appears to have made. Consider the peculiar phenomenon that defies our most fundamental understanding of thermodynamics, a counterintuitive occurrence where hot water freezes faster than cold water when placed in identical conditions within a freezer. This observation, named after Erasto Mpemba, a Tanzanian student who documented it in 1963, presents a direct challenge to the logical progression of temperature change that we expect from physics. When you place two containers of water at different starting temperatures into the same freezing environment, conventional reasoning dictates that the cooler water should solidify first, having less thermal energy to shed before reaching the crystalline state, yet repeatedly and consistently, experimenters observe that the warmer water completes its transformation into ice before its cooler counterpart. The mechanism driving this apparent violation of thermal logic remains genuinely contested among the scientific community, with researchers proposing multiple overlapping explanations, including the effects of convection currents that distribute heat more efficiently in warmer water, the phenomenon of supercooling where cooler water becomes trapped in a metastable state below freezing point without crystallizing evaporative cooling that removes more mass and therefore energy from the hotter sample, and the dissolution of dissolved gases which may facilitate faster freezing in freshly heated water. Despite decades of serious investigation and numerous documented instances of the effect's occurrence, no single explanation has achieved universal acceptance among physicists, and the Mpemba effect persists in that strange liminal space where reproducible observation contradicts our theoretical expectations, reminding us that even in domains we consider thoroughly understood and mechanistically explained, nature preserves mysteries that humble our confidence in complete comprehension of the physical world. Deep within the archives of NASA's Jet Propulsion Laboratory lies one of the most peculiar gravitational mysteries of the late 20th century, a phenomenon that quietly challenged our understanding of physics itself and continues to whisper unanswered questions even after decades of investigation. The Pioneer 10 and Pioneer 11 spacecraft, launched in the early 1970s as humanity's first emissaries toward the outer planets and beyond, exhibited a strange and persistent deviation from their predicted trajectories, a subtle but measurable acceleration pulling them back toward the sun with a force that defied conventional explanation. Throughout the 1980s and 90s, as these spacecraft transmitted their data across the vast emptiness of space, engineers noticed that the Pioneer probes were slowing down more rapidly than gravitational models suggested they should, as if some invisible hand were gently but relentlessly drawing them homeward. The anomaly was small, producing a deceleration of merely a few millimeters per second squared, yet it was consistent, measurable, and absolutely real, observable across both probes despite their different trajectories and construction details. Scientists proposed numerous explanations ranging from unaccounted solar radiation pressure to gravitational influences of undiscovered celestial bodies, yet none provided a completely satisfying resolution to the puzzle. Over the following years, researchers painstakingly examined every possibility, from thermal radiation emitted by the spacecraft themselves to the gravitational effects of the Kuiper belt, gradually accounting for most, but not all of the anomalous acceleration. Every single second, invisible particles called cosmic rays rain down upon Earth from the depths of space, traveling at nearly the speed of light and colliding with our atmosphere with energies so vast that our most powerful particle accelerators cannot replicate them. Yet we remain profoundly uncertain about where these particles actually originate. Scientists have known about cosmic rays for over a century, having discovered them through their ability to ionize air and create electrical currents in electroscopes. But despite decades of observation with increasingly sophisticated instruments, we still cannot definitively identify the sources of the highest energy cosmic rays, which represent one of the most energetic phenomena in the observable universe. The problem persists because cosmic rays arrive from all directions in space, and their paths curve unpredictably through magnetic fields permeating the galaxy, destroying any directional information that might point us back toward their birthplace, leaving us essentially blind to their origins. We have reasonable hypotheses that some cosmic rays originate from supernova explosions, the violent deaths of massive stars that scatter material outward with tremendous force, and others may come from active galactic nuclei, the mysterious powered cores of distant galaxies. Yet even these educated guesses fail to account for the most extreme ultra-high-energy cosmic rays whose power sources remain entirely unknown. The psychological mechanism driving our continued fascination involves the fundamental human desire to trace things back to their source, to understand causality and origin. Yet in this case, the universe itself seems designed to hide these answers from us through the very laws of physics that govern magnetic fields and particle behavior. Deep within the mathematical foundations of fluid dynamics lies a problem so fundamental yet so resistant to solution that it has resisted the efforts of the world's greatest minds for nearly 2 centuries. The Navier-Stokes equations, formulated in the 1820s, describe how fluids flow and interact with forces in our universe, governing everything from the movement of water through pipes to the swirling patterns of hurricane systems and the behavior of air around aircraft wings. Yet despite their apparent simplicity and elegant mathematical structure, these equations remain fundamentally unsolved in their three-dimensional form, meaning we cannot prove whether smooth solutions always exist or whether they might spontaneously develop infinite values in finite time. This is not merely an abstract academic curiosity, because every engineer, meteorologist, and physicist who attempts to model real fluid behavior must resort to approximations and computational simulations that work well enough in practice but lack rigorous mathematical justification. The psychological mechanism behind our acceptance of this mystery lies in a peculiar human tendency to compartmentalize knowledge. We have learned to build functional systems despite not fully understanding their underlying mathematics, much like we can ride bicycles without comprehending the differential equations governing their stability. Engineers pragmatically solve the equations numerically with computers, obtaining results that match observations closely enough for most purposes, which creates an illusion of understanding that masks the theoretical gap beneath. Our moon exists in orbit around Earth, a massive celestial body roughly 1/4 the size of our planet. Yet despite centuries of astronomical observation and decades of intensive scientific study, we remain fundamentally uncertain about how it actually came to be. The leading theory, known as the giant impact hypothesis, proposes that approximately 4.5 billion years ago, a Mars-sized celestial body collided with the early Earth in a catastrophic collision so violent that it liquefied both objects and ejected vast quantities of material into orbit, which subsequently coalesced into the moon we observe today. This theory emerged from computer simulations in the 1980s and has become the dominant model taught in universities worldwide. yet it persists despite numerous unresolved inconsistencies that should logically disqualify it from such universal acceptance. The Moon's chemical composition, particularly its isotopic ratios of oxygen and tungsten, matches Earth's composition far too closely, a similarity that the giant impact hypothesis struggles to adequately explain given the theoretical parameters of such a collision, which should have created a moon composed primarily of material from the impacting body rather than from Earth itself. Alternative theories persist in the scientific literature, including the capture hypothesis, which suggests the moon formed elsewhere and was gravitationally captured by Earth, and the fission theory, an older model proposing the moon separated directly from Earth's mantle. Yet these alternatives face their own substantial difficulties and lack the computational support that the giant impact hypothesis enjoys. Deep beneath the surface of our oceans, at depths where sunlight cannot penetrate and pressure would crush most living things, there exists a persistent low-frequency sound that has puzzled marine biologists and acousticians for decades. This phenomenon, often referred to as the ocean hum, is a constant rumbling that reverberates through the water column at frequencies so low that human ears cannot consciously perceive it, typically ranging between 5 and 10 Hz, existing just at the edge of our hearing threshold or entirely beyond it. Hydrophones deployed across the world's oceans have consistently recorded this mysterious sound emanating from seemingly everywhere at once, an omnipresent acoustic fog that fills the marine environment with an inexplicable drone. The hum appears to be increasing in intensity over time, correlating roughly with the expansion of commercial shipping traffic across global trade routes, yet the precise origin remains frustratingly elusive to scientific investigation. Researchers initially theorized that the sound originated from whale vocalizations, particularly the low-frequency calls of blue whales and fin whales that can travel thousands of miles through water, but detailed analysis of marine mammal behavior suggests that known cetacean calls cannot fully account for the ubiquity and constancy of the hum. Some scientists propose that the noise results from the collective vibration of millions of ships' propellers, creating a mechanical chorus that has fundamentally altered the acoustic landscape of Earth's oceans, while others suggest seismic activity, tectonic movement, or underwater volcanic processes might contribute significantly to the phenomenon. Deep within the fabric of our understanding of the early universe lies a peculiar discrepancy that has quietly puzzled cosmologists for decades, a gap between what the Big Bang theory predicts should exist and what we actually observe in the ancient stars and galaxies around us. When scientists examine the primordial abundance of lithium, one of the lightest elements created during the first few minutes after the Big Bang, they find that the universe contains significantly less of this element than every major cosmological model insists should be there, roughly 3 to 4 times less than predicted by the most robust calculations of Big Bang nucleosynthesis. This is not a minor measurement error or a small rounding discrepancy, but rather a profound inconsistency that suggests either our understanding of the early universe is fundamentally flawed, or there exists some unknown physical process that has systematically destroyed or hidden away vast quantities of primordial lithium throughout cosmic history. The psychological persistence of this mystery stems from an interesting human tendency to compartmentalize problems that do not immediately threaten our core understanding of reality. And because lithium represents only a tiny fraction of the universe's overall composition, it has been easy for the scientific community to treat it as a secondary concern rather than a potential window into deeper truths about fundamental physics. Yet the lithium problem refuses to disappear despite our collective desire for a complete and coherent cosmological narrative, and despite numerous proposed explanations involving exotic particles, modified nuclear reaction rates, stellar processes, or entirely new physics. No single solution has achieved consensus or fully resolved the tension. Every night, humans spend roughly 1/3 of their entire existence in a state of profound unconsciousness, vulnerable and motionless, yet neuroscience still cannot definitively explain why this happens or what essential function sleep actually serves. We know that sleep deprivation causes cognitive decline, emotional instability, and eventually death, suggesting that sleep is absolutely necessary for survival. Yet when researchers examine the specific mechanisms at work during sleep, the answers become frustratingly vague and contradictory. The brain does not simply shut down during sleep. Instead, it enters a dramatically different operational mode where certain neural networks activate intensely while others fall silent, creating a complex symphony of activity that seems purposeful yet remains largely inscrutable. Memory consolidation appears to occur during sleep, transforming short-term experiences into long-term storage, yet this process could theoretically happen during wakefulness without the biological cost of unconsciousness. Cellular repair and metabolic waste clearance accelerate during sleep, suggesting a maintenance function, but the brain manages constant repairs while awake as well. Emotional regulation stabilizes through sleep, preventing mood disorders and psychological deterioration. But again, this seems like a mechanism that should theoretically operate continuously. The puzzle deepens because we have normalized this mysterious void in our lives so completely that we rarely question why consciousness itself must vanish every single day, leaving us defenseless and unaware of our surroundings for hours at a time. In the early 2000s, astronomers observing data from the Fermi Gamma-ray Space Telescope made an astonishing discovery. Two enormous bubbles of gamma-ray emissions extending from the center of our Milky Way galaxy, stretching approximately 25,000 light-years above and below the galactic plane, structures so colossal and energetic that they seem to defy conventional understanding of how such phenomena could form or persist. These Fermi bubbles, as they came to be known, radiate across the electromagnetic spectrum with an intensity that suggests they were created by some titanic event. Yet the precise mechanism responsible for their generation and continued existence remains fundamentally mysterious and contested among astrophysicists worldwide. Multiple competing theories have emerged to explain their origin. Perhaps they were created by accretion events surrounding the supermassive black hole at our galaxy's center, Sagittarius A star, which periodically devours matter and releases unimaginable quantities of energy. Perhaps they resulted from countless supernovae explosions concentrated in the galactic core, their collective shockwaves accumulating into this bipolar structure. Or perhaps they represent the aftermath of some ancient relativistic jet that erupted from the black hole millions of years ago and has since cooled and expanded into the cosmic medium. The psychological mechanism underlying our fascination with these bubbles stems from their fundamental violation of our intuitive spatial expectations. For we inhabit a galaxy that appears comparatively calm and orderly from our local perspective. Yet here exists evidence of catastrophic cosmic violence operating at scales so enormous that human comprehension becomes nearly impossible, forcing us to confront the reality that our understanding of galactic physics remains fundamentally incomplete. You walk into a coffee shop you've never visited before, and something about the way the afternoon light falls across the wooden tables, the specific arrangement of chairs near the window, the cadence of the espresso machine in the background, suddenly feels like a memory you've already lived. Your brain sends a signal of profound familiarity, a ghostly echo suggesting you have been in this exact moment before, yet you know with absolute certainty that you have not. This is déjà vu, a phenomenon so common that most people experience it several times in their lives, yet its underlying mechanism remains stubbornly mysterious. The experience typically lasts only seconds to minutes, but in that brief window, reality seems to fracture between what you know to be true and what your neural pathways insist they recognize. Scientists have proposed numerous theories to explain this strange dissociation. One dominant hypothesis suggests that déjà vu occurs when there is a momentary glitch in memory processing, where current sensory information becomes briefly encoded into memory before conscious awareness fully registers the moment itself, creating an illusion of prior experience. Another theory proposes that we encounter subtle environmental similarities that our subconscious mind recognizes from previous experiences, even when our conscious mind cannot articulate what those connections are, triggering a false sense of familiarity without any corresponding memory we can access. Yet another explanation involves a delay in the neural systems responsible for novelty detection, suggesting that the brain's mechanisms for flagging new information misfire, incorrectly labeling fresh experiences as old ones. Despite decades of psychological and neuroscientific research, no single theory comprehensively explains all instances of déjà vu or why it happens more frequently in certain people or at certain times in life. Water behaves in ways that fundamentally violate the rules we expect from ordinary liquids, yet we have normalized these violations so completely that we rarely pause to consider how strange they truly are. Most liquids become denser as they cool, contracting steadily until they freeze into solid forms that sink below their liquid counterparts. But water refuses this logical progression and instead reaches maximum density at 4 degrees Celsius before becoming less dense as it approaches freezing, which is why ice floats on the surface of water rather than sinking to the bottom where one would mathematically expect it to go. This peculiar behavior has profound consequences for aquatic life, as it means that bodies of water freeze from the top down rather than from the bottom up, creating a protective insulating layer of ice that allows organisms beneath to survive through winters when the surface temperature plummets far below the freezing point. Yet we have accepted this inverted density curve as simply a property of water, rather than questioning why this particular substance alone, among common liquids, defies the fundamental principle of thermal contraction. Water also possesses an extraordinarily high heat capacity, meaning it requires far more energy to change its temperature compared to other substances, which is why large bodies of water moderate coastal climates, and why you can boil water for extended periods without the temperature rising, and this capacity seems disproportionate to the simple molecular structure we attribute to it. The surface tension of water is equally anomalous, creating a cohesive skin on its surface that allows small insects to walk across it as if traversing solid ground, a phenomenon that arises from hydrogen bonding between molecules. Yet the intensity and persistence of these bonds exceed what simple chemical calculations would predict. In the realm of quantum chromodynamics, one of the deepest puzzles in theoretical physics concerns why quarks and gluons, the fundamental particles that comprise protons and neutrons, can never be observed in isolation despite their theoretical necessity. When physicists heat matter to extraordinarily high temperatures or smash particles together at nearly the speed of light, they observe a phenomenon called asymptotic freedom, where the strong nuclear force weakens at shorter distances, allowing quarks to behave almost as free particles. Yet the moment energy levels drop or particles try to separate beyond a certain threshold, something mysterious occurs. The force suddenly strengthens dramatically, preventing any individual quark from escaping the confines of a hadron, creating an infinite energy barrier that makes isolation impossible. This sudden transition between weak and strong coupling represents the mass gap, a boundary where the mathematics of particle physics encounters a fundamental discontinuity that remains conceptually unexplained. The mass gap problem asks not merely how this transition occurs, but why massive composite particles like protons and neutrons emerge from massless or nearly massless quarks and gluons through this confinement mechanism, representing a mathematical and physical discontinuity that contemporary theory cannot adequately describe. Despite decades of computational simulations and theoretical frameworks, no complete explanation exists for why nature enforces this absolute barrier, why the mathematics itself seems to break down at this precise threshold, or how the transformation from point particles to measurable mass operates at the quantum level. The persistence of this mystery reflects how fundamentally incomplete our understanding remains regarding the basic structure of matter itself. Beneath your feet, at a depth of nearly 4,000 miles, exists a realm so extreme and so fundamentally alien to human experience that our understanding of it remains profoundly incomplete and riddled with uncertainty. The Earth's core represents perhaps one of the most inaccessible frontiers of scientific knowledge, a region we cannot directly observe, cannot physically sample, and cannot visit with any instrument we have ever created. We know the core exists, we understand it generates the magnetic field that protects all life on this planet, and we have developed sophisticated theoretical models based on seismic wave analysis. But the precise composition, the exact ratios of iron to nickel to lighter elements, the phase transitions occurring under conditions of impossible pressure and temperature, these remain subjects of considerable debate among geophysicists. The deepest hole ever drilled into the Earth reaches barely 6 miles down, a trivial scratch compared to the 4,000 miles separating us from the center, which means everything we claim to know about the core's composition is fundamentally an educated inference built upon indirect evidence and mathematical extrapolation. This gap between certainty and necessity, between what we confidently state in textbooks and what we actually can verify, creates a peculiar cognitive dissonance where we treat speculative models as established fact, presenting with absolute confidence compositions that remain theoretically contested. Our inability to penetrate this barrier stems not from lack of effort, but from the fundamental physics that make such a journey impossible. Yet we continue studying seismic waves, conducting high-pressure experiments in laboratories, and running sophisticated computer simulations as though these methods can somehow replace the direct observation we cannot achieve. Imagine a single bubble suspended in liquid, oscillating at an incredibly high frequency, expanding and contracting thousands of times per second as sound waves pass through it. And then suddenly, in the moment of its collapse, it emits a flash of light so bright and so brief that it exists for only billionths of a second. A phenomenon known as sonoluminescence that has puzzled physicists for decades because the mechanism by which sound energy converts into visible light remains fundamentally unexplained despite extensive laboratory study and theoretical modeling. When researchers first observed this effect in 1980, they documented that a single collapsing bubble could reach temperatures comparable to the surface of the sun, producing photons across multiple wavelengths of the electromagnetic spectrum. Yet the energy budget simply did not add up in ways that matched conventional thermodynamic predictions or standard quantum mechanical frameworks. The logical mechanism that should govern this process suggests that acoustic cavitation, the violent collapse of vapor cavities in liquids, generates enough heat and pressure to excite atoms and molecules into higher energy states, from which they should emit photons when returning to their ground state, a straightforward explanation that works in principle but fails mysteriously in practice because the actual light output sometimes exceeds what the input energy should theoretically permit. Scientists have proposed numerous theories including cosmic ray triggering, nuclear fusion reactions at microscopic scales, bioluminescent bacteria contamination, quantum vacuum fluctuations, and exotic particle production. Yet none of these explanations has achieved universal acceptance or satisfactorily resolved all the observational contradictions that emerge from different experimental conditions and variations. Deep beneath the Indonesian island of Flores, in a cave system known as Liang Bua, archaeologists discovered the skeletal remains of a species that shouldn't have existed, a hominin standing merely 3 feet tall with a brain the size of a chimpanzee, yet possessing tool-making capabilities and evidence of hunting large prey, a creature that lived alongside Komodo dragons and giant stegodon elephants until approximately 50,000 years ago. Fundamentally challenging everything we thought we understood about human evolution and the requirements for complex cognition. The discovery of Homo floresiensis, affectionately nicknamed the Hobbit, forced scientists to reconsider the very pathways through which intelligence and bipedalism emerge in the human family tree, suggesting that island isolation and dwarfism could produce cognitive abilities previously thought impossible at such diminished scales. Yet the origin of these creatures remains shrouded in profound mystery, with competing theories suggesting they descended from early African hominins like Homo erectus, who somehow navigated across vast oceanic distances to reach Flores, or alternatively, that they represent an entirely separate evolutionary branch whose origins trace back even further than current fossil records can confirm. The psychological mechanism underlying our fascination with the hobbit species stems from a fundamental human need to find exceptions to rules we believe we've established, to discover that our understanding of evolution, geography, and intelligence contains hidden chapters we've never read, allowing us to feel as though the world still contains genuine surprises and unknowable territories. Imagine observing the night sky with telescopes powerful enough to measure the rotational speeds of distant galaxies and discovering something that fundamentally contradicts the physics we have built our understanding upon, a contradiction so persistent and so widespread that it has forced us to reconsider the very composition of the universe itself. When astronomers measure how quickly the outer regions of galaxies rotate around their centers, they find velocities that should not exist according to the gravitational laws established by Newton and refined by Einstein, laws that have proven accurate for centuries when applied to planets, stars, and even black holes. The stars and gas clouds in the outer reaches of galaxies spin at speeds nearly as fast as those closer to the galactic center, which is equivalent to observing a merry-go-round where the outer horses move at the same velocity as those near the axis, something that the mathematics of gravity explicitly forbids unless we have fundamentally misunderstood what comprises a galaxy. The logical mechanism at work here reveals itself through calculation. Visible matter, the stars and dust and gas we can actually see when we point our instruments at these cosmic structures, simply does not contain enough mass to provide the gravitational force necessary to keep these outer regions moving at their observed speeds. By all conventional mathematics, these galaxies should be tearing themselves apart, their outer components flying away into the void like water droplets flung from a spinning wheel whose outer rim spins too fast to hold them. We have all experienced that peculiar moment when we reach for a doorknob and feel the sudden sharp sting of static electricity, a brief jolt that travels through our fingertips and startles us in the darkness, yet despite centuries of scientific advancement, the precise mechanism by which static electricity actually builds up and releases remains frustratingly obscure in ways that challenge our fundamental understanding of how matter behaves. When you walk across a carpeted floor on a dry day, electrons transfer between your shoes and the fibers beneath, accumulating an imbalance of charge on your body's surface, creating a potential difference that seeks resolution through the nearest conductive path, and this process seems straightforward enough when described in textbooks. Yet the actual quantum mechanics governing which electrons transfer, how they remain separated despite the electromagnetic forces trying to reunite them, and why the discharge occurs at such unpredictable moments remains genuinely mysterious even to physicists who study plasma and electrical phenomena professionally. The phenomenon involves the triboelectric effect, the tendency of materials to become electrically charged when they make contact with another substance. But we cannot reliably predict which material will become positively or negatively charged in a given interaction, nor can we fully explain why some insulators prevent charge from flowing while others allow it to slowly leak away, nor why humidity dramatically affects the entire process in ways that suggest atmospheric conditions influence quantum tunneling rates in ways we have not mathematically formalized. Deep within ice cores pulled from Antarctica and Greenland lie trapped air bubbles and isotopic signatures that tell us our planet has cycled through periods of extreme glaciation over millions of years. Yet the precise mechanisms that flip Earth from a temperate state into a frozen wasteland remain profoundly mysterious and contested among climatologists and paleoclimatologists alike. We know that ice ages arrive with a certain periodicity, roughly every 100,000 years or so, and we can identify correlations with variations in Earth's orbital parameters, particularly the Milankovitch cycles that alter how solar radiation strikes our planet, but the trigger itself, the exact threshold, the final push, the tipping point that causes global temperatures to plummet and massive ice sheets to accumulate across continents, eludes our complete understanding and continues to baffle researchers who have dedicated entire careers to solving this puzzle. The mystery deepens when we consider that small orbital variations alone cannot fully account for the magnitude of temperature change we observe in the geological record, suggesting that unknown feedback mechanisms must amplify these initial nudges, perhaps involving carbon dioxide sequestration, methane release from ocean sediments, changes in ocean circulation patterns, or alterations in planetary albedo as ice sheets expand and reflect more sunlight back into space. What remains genuinely unsettling is our inability to predict with confidence when the next ice age will arrive, or whether human activities have fundamentally altered the natural rhythms that govern these cycles for millions of years, leaving us uncertain about the climatic future we have inherited and the forces we may have inadvertently awakened or suppressed through our manipulation of atmospheric composition and planetary systems. On the morning of June 30th, 1908, in the remote Siberian wilderness near the Tunguska River, an explosion of unprecedented power flattened approximately 80 million trees across an area spanning 2,000 square kilometers, yet no impact crater was ever discovered at the epicenter, which is precisely what makes this event so profoundly puzzling to scientists even more than a century later. The blast was so powerful that it released energy equivalent to between 10 and 15 megatons of TNT, making it 1,000 times stronger than the atomic bomb dropped on Hiroshima. And yet the explosion left behind almost no physical evidence of what caused it, no meteorite fragments, no distinctive crater formation, and no consistent eyewitness accounts from the sparsely populated region. The leading hypothesis suggests that a stony meteorite or comet fragment entered Earth's atmosphere and exploded at an altitude of several kilometers above the ground before striking the surface, a phenomenon known as an airburst, which would explain the flattened vegetation pattern and the absence of a traditional impact crater. However, the complete lack of recovered meteoritic material contradicts what we would normally expect from such an event, as similar impacts throughout geological history have left behind measurable fragments and chemical signatures that allow researchers to analyze their composition. The mystery persists because our conventional models of celestial impacts, developed through countless observed phenomena and laboratory experiments, cannot fully account for why an explosion this magnitude would leave virtually no trace of its source material, creating a haunting gap between what the physics predicts and what the forensic evidence reveals. Deep within the atmospheric layers of Saturn, suspended near the planet's north pole, exists a geometric formation so impossibly regular that it seems to violate the fundamental principles of fluid dynamics that govern planetary atmospheres. A massive hexagonal storm system that has persisted for at least 50 years, possibly far longer. This hexagon measures approximately 14,000 miles across, roughly the same width as Earth itself, and its edges remain defined by a jet stream traveling at speeds exceeding 200 miles per hour, while the interior churns with winds and cloud formations that cycle through colors of gold and amber and deep blue. The shape itself is the profound mystery, for in the turbulent chaos of a gas giant's weather systems, where wind patterns swirl and merge and dissipate according to chaotic mathematics and thermal gradients, a perfect hexagon should not persist. Random fluid motion produces circular vortices and elongated storms and irregular structures that evolve constantly. Yet Saturn's hexagon maintains its geometric precision through decades, its 6 sides remaining symmetrical, its angles sharp, its overall form stable, while the very substance it contains moves and changes. Scientists have proposed that this shape emerges from the interaction of multiple jet streams at different altitudes, where rotating flows can create standing wave patterns that reinforce geometric structures, similar to how standing waves in a vibrating string produce regular patterns rather than chaos. The hexagon may represent a rare equilibrium point where competing atmospheric forces achieve balance, where the mathematics of fluid dynamics at this particular latitude and rotation rate and thermal condition naturally produces six-fold symmetry. Deep within the oceans of our planet, a process occurs that remains fundamentally mysterious despite centuries of chemical study, and it involves the formation of bicarbonate ions, those peculiar molecular entities that seem to exist in a kind of chemical limbo between acid and base, neither fully committed to either state. When carbon dioxide dissolves in water, it undergoes a series of reactions that should, by all logical accounts, produce predictable and straightforward results. Yet the formation of bicarbonate ions defies complete understanding in ways that continue to perplex marine chemists and geochemists around the world. The carbon dioxide molecule enters the water and theoretically combines with water molecules to form carbonic acid, which should then dissociate into hydrogen ions and bicarbonate ions through a mechanism we believe we understand. Yet the precise kinetics of this process, the exact rates at which these transformations occur under varying conditions of temperature, pressure, and salinity, remain largely incomprehensible. The mystery deepens when we consider that bicarbonate appears to serve as a crucial buffer in our oceans, maintaining pH stability despite the constant influx of acidic compounds. Yet we cannot fully explain why this particular ion configuration proves so effective at this role, or why nature selected this seemingly random molecular arrangement as the primary mechanism for regulating oceanic chemistry. The formation of bicarbonate also presents a temporal paradox of sorts, where the reaction should occur instantaneously according to our models, yet observations suggest subtle delays and variations that cannot be accounted for by current chemical theory. We have mapped the surface of the moon with greater precision than we have mapped the floor of our own oceans, a fact that settles into the mind like a stone dropping through fathomless water. The ocean covers more than 70% of Earth's surface, yet we have explored less than 5% of it, leaving nearly 95% of this vast aquatic realm shrouded in absolute darkness and mystery. The deepest parts of the ocean, the hadal zones beyond 7,000 meters, remain so remote and hostile that fewer humans have visited these trenches than have journeyed into space itself, a circumstance that seems almost paradoxical given that water exists in relative proximity to where most of humanity lives. The pressure at these depths reaches crushing magnitudes, temperatures hover just above freezing, and the darkness is so complete that it represents a form of sensory deprivation we struggle to truly comprehend. This mysterious frontier persists partly because the technological and financial barriers to deep ocean exploration dwarf those of space travel, yet partly also because the ocean depths have maintained their psychological distance from human consciousness despite their literal closeness to our civilization. We have normalized the ignorance surrounding the deepest trenches by transforming them into symbols of the unreachable rather than calling them what they are. Places we have simply chosen not to visit with any regularity or systematic intention. The creatures that inhabit these regions remain so poorly understood that new species are discovered constantly, and there exists the genuine possibility that entire ecosystems thrive in isolation, unknown and undocumented, following evolutionary paths that diverged from all our assumptions about how life itself should function. Every day, without fail, you open your mouth wide and draw in a long breath, your jaw stretching to its limits while your eyes water, and your entire face contorts into an expression of profound fatigue. And yet, despite this being one of the most universal behaviors across all mammals and even some reptiles, science still cannot definitively explain why we do it or what evolutionary advantage it provides. You might assume that yawning is simply a response to tiredness, a signal from your body that it needs sleep. But the evidence contradicts this neat explanation because people yawn when they are wide awake, when they are excited, when they are bored, when they are stressed, and even when they are watching other people yawn, suggesting that the behavior is far more complex and mysterious than mere fatigue management. Researchers have proposed numerous theories over the decades, from the idea that yawning increases oxygen intake to the brain, to the notion that it regulates body temperature by cooling the blood vessels in the face, to the psychological suggestion that it is a contagious empathy response that bonds social groups together. Yet none of these explanations have been proven conclusively or account for all instances of yawning across different contexts. The contagious nature of yawning is perhaps the most bewildering aspect because when you see another person yawn, you feel an almost irresistible urge to yawn yourself, a phenomenon that occurs even when viewing photographs or reading about yawning, and this behavioral mirroring appears to be linked to theory of mind and social bonding. Yet we cannot understand why evolution would hardwire us to involuntarily replicate a behavior whose original purpose remains obscure. Deep within the Western Sahara Desert, roughly 300 kilometers east of Mauritania's coastal city of Nouakchott, there exists a geological formation so perfectly circular and so geometrically precise that astronauts first noticed it from orbit and initially believed it to be an artificial structure of unknown origin. The Richat structure, colloquially known as the Sahara Eye, spans roughly 50 kilometers in diameter and consists of concentric rings of rock that alternate between lighter and darker mineral compositions, creating the unmistakable appearance of an enormous eye staring upward into the heavens. The formation has captivated geologists, researchers, and casual observers alike for decades. Yet the precise mechanism of its formation remains deeply contested and fundamentally unclear, with multiple competing hypotheses that all contain significant gaps in their explanatory power. The most widely accepted theory suggests that the structure resulted from a meteorite impact followed by erosion of the uplifted central dome. Yet the absence of a confirmed impact crater and the presence of crystalline rock formations that don't match typical impact signatures make this explanation incomplete. Alternative theories propose salt dome intrusion, volcanic activity, or the collapse of a subsurface chamber, but each of these carries its own complications and inconsistencies when examined against the actual geological record. What remains genuinely mysterious is not merely the structure's origin, but how such perfect geometric symmetry could emerge from natural processes, and why the erosion patterns radiate outward with such remarkable uniformity. Imagine you're handed a completed jigsaw puzzle and asked to verify whether all the pieces fit together correctly, a task that takes you mere minutes to complete. Yet assembling that same puzzle from scratch would require hours of painstaking trial and error, and this fundamental symmetry between checking a solution and finding one lies at the heart of one of mathematics and computer science's deepest unsolved mysteries, known as the P versus NP problem. In the theoretical world of computational complexity, the letter P represents problems that computers can solve quickly, meaning a solution can be found in what mathematicians call polynomial time, which is essentially a reasonable amount of computational effort that grows predictably with the size of the problem, while NP represents a broader category of problems whose solutions, once proposed, can be verified quickly even if finding them initially seemed impossibly difficult. And the essential question haunting researchers for decades is whether these two categories are actually equivalent, whether P equals NP, and if so, whether every problem whose solution can be verified quickly can also be solved quickly, a revelation that would fundamentally reshape our understanding of computation itself. The psychological weight of this unsolved problem stems from its staggering implications for cryptography, optimization, artificial intelligence, and virtually every computational process that underpins modern civilization. Because if P truly equals NP, then all the encryption protecting your financial transactions, your personal communications, and your digital identity would become theoretically breakable. Yet simultaneously, all optimization problems that currently require extensive searching could be solved instantly, meaning traffic patterns could be optimized perfectly, drug molecules could be designed with unprecedented efficiency, and countless intractable problems would suddenly become solvable. High above the Earth's atmosphere, in the depths of space that surround our solar system, there exists a faint triangular glow that appears near the horizon during twilight hours, a phenomenon known as zodiacal light that remains one of astronomy's most perplexing unsolved mysteries regarding its precise composition and origin. This ethereal illumination, visible only under the darkest skies far from light pollution, stretches upward from the sun's position along the ecliptic plane, creating what observers have described for centuries as a luminous pyramid of light that seems to defy conventional understanding of how dust particles should behave in the vacuum of space. Scientists have determined that this glow is caused by interplanetary dust, microscopic particles of matter scattered throughout the inner solar system. Yet the exact mechanisms that maintain, replenish, and distribute this dust remain profoundly unclear despite decades of dedicated observation and theoretical modeling. The dust particles themselves appear to be composed of silicates and carbon-based materials, likely originating from asteroid collisions, comet debris, and perhaps even contributions from the outer edges of our solar system being drawn inward by gravitational forces. Yet astronomers cannot fully explain why the dust maintains such a consistent and visible distribution pattern rather than dispersing randomly throughout space. What makes this phenomenon particularly puzzling is the apparent stability of the zodiacal light, despite the numerous forces that should theoretically scatter and eliminate these particles over astronomical timescales, including solar radiation pressure, solar wind interactions, and collisions between dust grains themselves. Water, the most abundant and essential substance on our planet, behaves in ways that fundamentally contradict what we would expect from basic chemistry and physics, and these anomalies have persisted at the very edge of scientific understanding for decades. Unlike nearly every other liquid known to exist, water expands when it freezes rather than contracts, a property so unusual that ice floats on its liquid form, while the frozen versions of almost every other substance sink to the bottom of their parent liquids. And this single deviation from predictable behavior has allowed aquatic life to survive beneath frozen surfaces throughout Earth's history. Beyond this well-known peculiarity, water exhibits an inexplicably high specific heat capacity, meaning it requires far more energy to change its temperature than would be predicted by molecular weight alone, which is why oceans regulate global climate with such remarkable stability, and why coastal regions experience milder temperature fluctuations than inland areas. Water molecules also demonstrate extraordinary cohesion and surface tension, clinging to themselves with a strength that seems disproportionate to their structure, allowing insects to walk across surfaces and enabling capillary action that defies gravitational logic, pulling liquids upward through thin tubes as if possessed by invisible forces. Perhaps most mysteriously, water exists in a perpetual state of partial structure even in its liquid form, with hydrogen bonds constantly forming and breaking in patterns that suggest some underlying organization that science has yet to fully comprehend, and when subjected to various frequencies of sound or exposure to certain electromagnetic fields, water's behavior becomes even more enigmatic, though these observations remain controversial within mainstream scientific communities. Despite living in an age where we can predict weather patterns weeks in advance, map distant galaxies, and model complex climate systems with remarkable precision, our ability to forecast earthquakes remains virtually non-existent, a gap in human knowledge that persists with an almost stubborn indifference to our technological progress. Seismologists can detect earthquakes with extraordinary accuracy after they occur, measuring their magnitude, locating their epicenter, and analyzing the waves that radiate through the Earth with mathematical precision. Yet the moment before a major quake strikes remains entirely opaque to science, as though nature has drawn an impenetrable veil across this particular threshold of prediction. We understand the broad mechanisms involved. Tectonic plates shift along fault lines, pressure accumulates over decades or centuries, and eventually the stress releases in a catastrophic movement. Yet translating this knowledge into actual predictive capability has proven to be one of the most humbling failures in modern science. Countless research programs have attempted to find precursory signals, anomalous animal behavior, changes in electrical fields, unusual gas emissions, variations in groundwater levels. And while anecdotes of animals fleeing before disasters circulate through popular culture with persistent conviction, rigorous scientific studies have failed to establish reliable correlations that could form the basis for genuine prediction systems. The psychological mechanism behind this failure likely stems from our deep human need to impose order and control upon chaotic natural phenomena, a need so fundamental that we continue funding prediction research and occasionally celebrate minor advances as though they represent genuine breakthroughs when they represent only statistical noise. Among all the planets in our solar system, Venus stands as perhaps the most perplexing celestial anomaly, rotating backwards on its axis in a phenomenon known as retrograde rotation, moving clockwise when viewed from above the North Pole rather than counterclockwise like nearly every other body in our cosmic neighborhood. What makes this backward spin even more mysterious is that Venus rotates so slowly, taking approximately 243 Earth days to complete a single rotation, meaning that a day on Venus is actually longer than its year, which lasts merely 225 Earth days, creating a temporal paradox that defies our conventional understanding of planetary mechanics. Scientists have proposed several hypotheses to explain this unusual orientation, with the most prominent theory suggesting that Venus may have been struck by one or more massive planetary bodies early in solar system formation, collisions powerful enough to reverse its original rotation and subsequently slow it to its current glacial pace. Yet despite centuries of astronomical observation and decades of direct planetary exploration through various spacecraft missions, we have never directly witnessed the mechanism that could produce such a dramatic reorientation. Nor can we definitively prove that impact scenarios would generate the precise conditions necessary for this particular rotational state. The mystery deepens when we consider that Venus also exhibits an unusual atmospheric superrotation, where winds in its upper atmosphere circle the planet in just 4 Earth days, contradicting the slow surface rotation and suggesting entirely separate weather systems operating by completely different dynamics. Imagine a young spider, no more than a millimeter in length, climbing to the highest point it can find and pointing its abdomen toward the sky, releasing gossamer-thin strands of silk into the wind until it simply lifts off the ground and floats away into the atmosphere, traveling potentially hundreds of miles across oceans and continents suspended by nothing but these invisible threads so delicate they remain largely invisible to the human eye. This phenomenon, known as spider ballooning, occurs in thousands of spider species around the world, and researchers have documented spiders ascending to altitudes of over 10,000 feet, riding atmospheric currents at speeds that would carry them across entire landscapes in a matter of hours. Yet despite more than a century of scientific observation and countless experiments designed to understand this behavior, the fundamental mechanisms that allow spiders to sense wind conditions, to know precisely when atmospheric conditions are favorable for launching, and to navigate while suspended in the air remain deeply mysterious. Scientists struggle with basic questions about how spiders detect the electrical fields that may guide their dispersal, how they determine which direction they are traveling while surrounded by invisible air currents, and how they manage to land safely and unharmed after traveling such extreme distances. The ballooning behavior itself appears to serve an evolutionary purpose in population dispersal, allowing young spiders to escape overcrowded habitats and establish new colonies in distant locations. Yet the specifics of how this internal navigation system operates, how the spiders sense their velocity and altitude, and what triggers the decision to launch remain frustratingly elusive despite intensive research efforts. Saturn's moon Titan presents one of the most perplexing atmospheric mysteries in our solar system, a puzzle that has confounded planetary scientists since the Cassini spacecraft first arrived at Saturn in 2004. Titan possesses a thick atmosphere composed primarily of nitrogen, but woven throughout this gaseous envelope is methane, a simple organic compound that should not exist in the quantities we observe there. The fundamental problem lies in the fact that methane is extraordinarily unstable when exposed to ultraviolet radiation from the distant sun, breaking down through photochemical reactions into more complex organic molecules in a process that should completely eliminate atmospheric methane within approximately 10 million years, a mere blink of an eye in cosmic timescales. Yet Titan's methane concentrations remain robust and persistent, suggesting that some unknown source continuously replenishes what ultraviolet light destroys, a resupply mechanism that remains maddeningly elusive despite decades of dedicated observation. Scientists have proposed numerous hypotheses to explain this methane source, ranging from cryovolcanism, wherein eruptions of water and organic compounds from beneath Titan's icy crust could release methane into the atmosphere, to subsurface microbial life that might produce methane through biological metabolic processes deep within a hypothetical liquid water ocean hidden beneath the moon's frozen surface. Yet each explanation carries significant complications and requires assumptions that extend far beyond what current evidence can support, leaving us in a state of genuine uncertainty about one of the solar system's most fundamental atmospheric riddles. Every day, millions of people around the world undergo surgical procedures while rendered completely unconscious by chemical compounds that we still do not fully understand. And this fundamental gap in our knowledge persists at the very heart of modern medicine, despite being one of the most routinely administered interventions in human healthcare. When you receive a general anesthetic before surgery, whether it is propofol, sevoflurane, isoflurane, or any of the dozens of other agents in the anesthesiologist's arsenal, your consciousness simply ceases, your body becomes paralyzed and insensate, and yet we cannot definitively explain the precise molecular mechanism by which this profound neurological transformation actually occurs. The mystery deepens when you consider that these drugs work across species, across different brain structures, and across an enormous range of chemical configurations, suggesting that whatever they do, they tap into something fundamental about consciousness itself, yet this fundamental something remains deeply elusive to scientific scrutiny. We know that general anesthetics bind to certain proteins and ion channels in the brain. We know they disrupt the transmission of neural signals in particular ways, and we know empirically that they work with remarkable consistency, but the actual causal chain that connects molecular action to loss of consciousness remains fragmented and incomplete, with competing theories rather than unified understanding. Some researchers propose that anesthetics disrupt the integrated information processing that supposedly generates consciousness. Others suggest they work by enhancing inhibitory signals. Still others argue they create a kind of neural noise that prevents the coherent activity necessary for awareness. And yet none of these theories fully explain why these chemically diverse molecules all produce the same profound effect. Deep beneath the Earth's crust, in places where humans have never ventured and light has never reached, vast quantities of hydrogen gas appear to be generated through processes we barely understand, emerging from rock formations in ways that challenge our fundamental assumptions about planetary chemistry and energy cycles. This phenomenon, sometimes called white hydrogen or geological hydrogen, has been detected in various locations around the world, from abandoned mines in France to deep boreholes in Africa, and yet its origins remain profoundly mysterious despite decades of geological investigation. The hydrogen exists in concentrations far too high to be explained by conventional weathering processes or bacterial activity alone, suggesting that some unknown mechanism deep within the planetary interior is actively producing this gas and allowing it to migrate upward through fissures and permeable rock layers. Scientists have proposed several theories, including radiolytic water splitting caused by natural radioactive decay within the Earth's crust, chemical reactions between water and certain iron-rich minerals, or even biological processes occurring in subsurface ecosystems we have yet to properly characterize. Yet none of these explanations fully accounts for the observed quantities and distribution patterns. The persistence of this mystery is particularly striking because the implications are enormous. If hydrogen is continuously generated within the Earth at substantial rates, it represents an enormous potential energy source that remains almost entirely untapped and unexplored. Yet we continue to invest our resources into surface-level renewable technologies, while the planet itself may be actively producing fuel in its depths. Across North America, a biological phenomenon unfolds each autumn with mathematical precision that defies every rational framework we possess about animal cognition and spatial awareness. Monarch butterflies, weighing less than a single gram, undertake a multi-generational migration spanning up to 3,000 miles from the Canadian forests to the mountain forests of central Mexico. A journey that no individual butterfly has ever completed before, and no individual butterfly will ever complete again after their first attempt. The butterflies born in late summer possess an innate compass calibrated to magnetic fields, polarized light patterns, and the position of the sun. Yet this is only the beginning of the mystery that surrounds them. These delicate creatures navigate with accuracy that would require instruments and calculations far beyond their microscopic neural architecture, somehow encoding directional information into a brain the size of a sesame seed, following routes across landscapes they have never seen before, across continents they have no learned experience of traversing. The mechanism they employ remains fundamentally incomprehensible, because while we have documented that they possess magnetoreceptive proteins and light-sensitive neurons, we cannot reconcile how these biological components translate into the sophisticated, adaptive navigation system they demonstrate in practice. The butterflies adjust their course for wind patterns, for geographic obstacles, for seasonal weather variations, exhibiting a flexibility in their route that suggests planning and decision-making rather than simple programming. Yet we possess no framework for understanding consciousness or intentionality at such a scale. Among the most distant and luminous objects in the entire observable universe, quasars present a problem so profound that it fundamentally challenges our understanding of how energy itself can be concentrated and released in the cosmos. A single quasar can outshine an entire galaxy containing billions of stars, radiating more energy in a single second than our sun will emit across its entire 10 billion-year lifespan. Yet these objects appear to be powered by engines no larger than our solar system, perhaps even smaller than the orbit of Neptune. The energy densities required to explain their luminosity seem to violate intuitive principles about how matter and energy should behave, and the source mechanism driving this incomprehensible power output remains shrouded in theoretical uncertainty. We believe that supermassive black holes at the centers of distant galaxies may be responsible, drawing in material and converting gravitational potential energy into radiation with extraordinary efficiency. Yet the exact mechanics of how this conversion occurs, how the energy can be collimated into narrow jets traveling at nearly light speed, and why some quasars behave erratically while others remain stable, continues to perplex astrophysicists. The problem deepens when we consider that we are observing these objects as they existed billions of years ago, meaning that the universe in its youth was somehow capable of generating far more luminous quasars than we see in the nearby universe today, suggesting either that the conditions for creating such objects have fundamentally changed, or that we misunderstand the physical processes entirely. We have normalized this mystery by accepting that black hole accretion provides the explanation. Yet this explanation itself relies on mechanisms that push the boundaries of known physics, involving space-time distortion, relativistic jets, and energy conversion rates that seem almost too perfect to occur naturally. Beneath the surface of our planet, at depths where sunlight has never penetrated and pressure would crush most organisms instantly, scientists have discovered thriving communities of microbial life that seem to operate according to rules we do not fully understand. These deep subsurface microbes exist in the Earth's crust, in geological formations miles below our feet, in places where they should theoretically be unable to survive, yet they persist in such abundance that their total biomass may rival or exceed all surface life combined. These organisms appear to derive energy from sources fundamentally different from those that sustain surface ecosystems, drawing power from chemical reactions between rock and water, from radioactive decay within the planet's interior, from hydrogen and methane seeping through fractures in ancient stone. The discovery of these microbes in such hostile environments forced scientists to completely reconsider what constitutes the boundaries of the habitable zone, expanding it downward into the Earth itself in ways that challenged our understanding of life's basic requirements. Yet despite decades of research, we remain profoundly ignorant about these creatures. We cannot reliably predict where they will be found or in what concentrations. We struggle to understand their metabolic processes and reproductive cycles, and most unsettling, we cannot determine whether what we are studying in our laboratories actually represents their natural state or merely artifacts of the extreme disturbance caused by drilling and extraction. The sheer scale of this hidden biosphere raises questions we have normalized without answering. If life thrives in such abundance in conditions we once deemed impossible, what does this say about life's resilience elsewhere in the universe? Deep within the outer reaches of our solar system, beyond the orbit of Neptune where sunlight arrives as merely a whisper, astronomers have detected something profoundly strange: gravitational anomalies that seem to suggest the presence of a massive, undiscovered planet orbiting in the shadows of our cosmic neighborhood. In 2016, researchers Konstantin Batygin and Mike Brown from the California Institute of Technology published findings showing that the orbital patterns of distant icy bodies, known as transneptunian objects, appeared to be influenced by a gravitational force that shouldn't exist according to our current astronomical surveys, as if some invisible giant were herding these distant worlds along invisible pathways through space. The mathematical models suggested this hypothetical world, termed Planet 9, would be approximately 10 times the mass of Earth, traveling in an enormously elongated orbit that takes it far beyond the Kuiper belt into regions we have never directly observed. Yet despite decades of increasingly sophisticated telescopes, ground-based observatories, and space-based instruments capable of detecting light from the most distant galaxies, no one has actually seen this planet, which creates a peculiar psychological tension within the scientific community between the compelling mathematical evidence and the frustrating absence of direct confirmation. The phenomenon reveals how modern astronomy has become comfortable with the idea of inferring invisible objects through their gravitational influence rather than requiring direct visual proof. A shift in epistemology that represents both tremendous scientific advancement and a fundamental leap of faith that our mathematical models truly capture reality. When you hold a piece of ordinary glass in your hand, you are touching something that exists in a state of profound physical ambiguity, a substance that refuses to behave according to the rules that govern either liquids or solids, and scientists still cannot fully explain why this happens or what is truly occurring at the molecular level when glass undergoes its strange transformation. Glass transition is the phenomenon where a material like silica suddenly loses its ability to flow like a liquid and becomes rigid like a solid, yet it does not crystallize in the traditional sense, and instead enters a glassy state that defies the conventional categories of matter that we have long understood. When molten glass cools below its transition temperature, something remarkable occurs. The atoms do not arrange themselves into the ordered, repeating patterns that define a crystal, but instead become frozen in a disordered, amorphous configuration that resembles liquid structure far more than solid structure, creating what physicists call an arrested liquid or a non-equilibrium solid. The mystery deepens when you consider that there is no clear thermodynamic explanation for why atoms would suddenly stop moving cooperatively and instead lock into place in this specific temperature range. Because mathematically and energetically, there should be no sharp boundary where this occurs. Yet experimentally, we observe one consistently. Scientists have proposed numerous theories involving entropy, viscosity, free volume, and molecular cooperativity, yet none have achieved universal acceptance or fully reconciled the gap between what we measure and what we predict, suggesting that something fundamental about the nature of disordered matter and the transition between states remains hidden from our current understanding, waiting in the space between liquid and solid where the rules we thought we knew simply stop applying. In 2015, astronomers discovered something profoundly unsettling when analyzing data from the Kepler Space Telescope, a discovery that would eventually challenge our fundamental understanding of stellar behavior and the possibilities lurking within our own galaxy. A star designated KIC 84648552, or more commonly known as Tabby's star, located roughly 1,400 light-years away in the constellation Cygnus, began exhibiting dimming patterns so irregular and so dramatic that they defied conventional astronomical explanation. The star would fade and brighten in ways that seemed almost algorithmic, dropping in brightness by up to 22% over short periods of time, behavior that contradicts everything we understand about how mature stars should behave. Traditional stellar dimming caused by dust, by planets, by stellar activity, or by binary companion stars all follow predictable mathematical patterns that astronomers have cataloged and understood for centuries, yet Tabby's star refused to conform to any of these established models. The dimming appeared episodic and asymmetrical, with deep dips lasting days or weeks followed by irregular recovery periods that made no sense through conventional physics. As observations continued, the star seemed to exhibit long-term dimming trends as well, losing brightness gradually over months and years in a way that suggested something massive was gradually obscuring the star's light. Scientists proposed increasingly exotic explanations including comet swarms, fragments from a shattered planetary system, massive artificial megastructures built by advanced civilizations, or clouds of exotic matter responding to unknown forces. Imagine collapsing the entire mass of our Sun into a sphere no larger than a city, and you begin to approach the incomprehensible density of a neutron star, those remnants of stellar explosions that represent perhaps the most extreme laboratories of physics known to exist in the universe. When a massive star reaches the end of its life and collapses catastrophically inward, electrons are forced into protons to create neutrons, and what remains is a celestial object so dense that a single teaspoon of its material would weigh as much as all the cars ever manufactured on Earth combined. Yet we possess only theoretical models of what actually exists within these stellar corpses. The scientific mystery persists because the conditions at the core of a neutron star exceed anything we can replicate in laboratories, where pressures and temperatures reach values so extreme that matter itself behaves in ways that challenge our most fundamental equations of physics and quantum mechanics. Scientists have theorized exotic states of matter within these stellar remnants, including quark soup, strange matter, and crystalline structures of iron harder than anything imaginable. But the fundamental architecture of a neutron star's interior remains hidden behind an event horizon of compressed matter and radiation that renders direct observation nearly impossible. We have normalized this profound mystery by treating neutron stars as established objects of study, confidently incorporating them into our cosmic models and astronomical surveys. Yet the truth is that the deepest interior of these objects represents perhaps the greatest unknown in astrophysics, a realm where general relativity and quantum mechanics potentially break down entirely. Consider for a moment the remarkable and perplexing life cycle of the European eel, a creature that has confounded marine biologists for centuries with a reproductive process so enigmatic that we have never once directly observed it occurring in nature. These eels spend the majority of their lives in freshwater rivers and lakes across Europe, growing and developing over years or even decades. Yet when they reach a certain developmental threshold, something within them triggers an irresistible compulsion to return to the sea, specifically to the Sargasso Sea, a region of the Atlantic Ocean located thousands of kilometers away. They cease eating, their bodies transform physiologically, their eyes enlarge, and they begin their perilous journey downstream toward the ocean with an internal navigation system we have yet to fully comprehend. Once they reach the sea, they embark on this extraordinary migration, but here is where the mystery deepens profoundly. No human has ever witnessed an adult eel actually breeding, no scientist has ever found a breeding population in the Sargasso Sea, and no one has ever collected eggs or larvae that definitively belong to breeding eels in their natural environment. We know they must breed somewhere because young glass eels and leptosphaly larvae somehow find their way back to European coastlines, yet the actual act of reproduction remains completely hidden from human observation. The psychological mechanism that allows us to accept this profound gap in our understanding is our tendency to treat incomplete knowledge as sufficient knowledge, to accept that migration occurs because we can track the beginning and the end, even though the most crucial middle section remains entirely invisible. The Bermuda Triangle refers to a loosely defined region in the western part of the North Atlantic Ocean, roughly bounded by Miami, Bermuda, and Puerto Rico, where numerous ships and aircraft have allegedly disappeared under mysterious circumstances over the past several centuries. Yet the scientific reality of this phenomenon remains far more mundane than popular culture suggests. The actual disappearances that have occurred within this region can be traced to documented causes, including sudden and severe weather patterns, the presence of methane hydrate deposits on the ocean floor that reduce water density and can cause ships to sink rapidly without warning, magnetic anomalies that occasionally interfere with compass navigation, and human error compounded by the naturally treacherous conditions of the Atlantic seaboard. All of which are well understood through oceanographic and meteorological research. What is particularly fascinating is how the Bermuda Triangle persists as a cultural phenomenon and perceived mystery, despite decades of thorough investigation by insurance companies, maritime authorities, and scientific organizations that have found no statistical anomaly in the rate of disappearances within the triangle, compared to any other heavily trafficked ocean region of similar size and environmental complexity. The psychological mechanism sustaining belief in the Bermuda Triangle's supernatural or anomalous properties appears rooted in our tendency toward pattern recognition and narrative coherence, where isolated incidents spanning different time periods and vastly different circumstances become woven into a singular explanatory framework that feels more compelling than acknowledging randomness and natural hazard. In 1997, the United States National Oceanic and Atmospheric Administration's Underwater Hydrophone Network detected an extraordinarily loud, low-frequency sound emanating from somewhere in the South Pacific Ocean, a noise so powerful that it registered on sensors stationed thousands of miles apart, yet so deeply mysterious that more than 2 decades later, its origin remains one of the most haunting enigmas in marine science. The sound, which scientists nicknamed the bloop because of its characteristic acoustic signature, was loud enough to be heard by equipment positioned near Antarctica, Chile, and Hawaii simultaneously, suggesting a source of immense power moving through the depths. Yet no vessel, no underwater volcano, no known geological event matched the temporal signature of this acoustic event. The initial hypothesis, almost romantically embraced by the public imagination, proposed that the sound originated from an impossibly massive, undiscovered deep-sea creature, perhaps a squid or whale of unprecedented dimensions, living in the darkness of the abyssal zones where sunlight never penetrates and pressure would crush most known life forms into oblivion. However, scientists gradually concluded through acoustic analysis and careful examination of the sound's characteristics that the bloop likely resulted from the calving of icebergs from the Ross Ice Shelf in Antarctica, where massive sheets of ice fracture and collapse into the sea, creating powerful vibrations that propagate through water with remarkable efficiency and clarity. Deep within the fabric of our universe lies a phenomenon so vast and so empty that it challenges our fundamental understanding of how matter distributes itself across space, and this phenomenon is known as cosmic voids. These are regions of the universe where the density of matter drops to nearly 1/10 of the cosmic average, creating vast spherical or elongated bubbles of near-nothingness that stretch for hundreds of millions of light-years in every direction. The largest known void, the Boötes void, spans a distance of roughly 340 million light-years across, and contains so few galaxies relative to its volume that the mind struggles to conceptualize the sheer emptiness involved. Yet despite decades of observation and theoretical modeling, astronomers cannot fully explain why these voids exist in their current configuration, nor can they predict with certainty how voids form and evolve over cosmic time. The leading theories suggest that quantum fluctuations in the early universe were amplified by inflation, causing slight density variations that eventually grew through gravitational dynamics, with matter being pulled away from underdense regions toward denser regions, leaving behind these enormous cavities. However, the precise mechanisms governing void formation, the rates at which they expand, and their long-term stability remain deeply mysterious and subject to ongoing debate. What makes this particularly unsettling is that we have normalized living in this incompletely understood cosmic structure, accepting voids as ordinary features of the universe despite the fact that our models predict them should behave differently than observations indicate. We construct elaborate simulations and refine our gravitational theories, yet voids continue to present inconsistencies that suggest something fundamental about large-scale structure formation still escapes our comprehension. Deep within laboratories around the world, scientists cool certain materials to temperatures approaching absolute zero and something extraordinary happens. Electrical resistance vanishes entirely, allowing electric current to flow forever without any loss of energy whatsoever, a phenomenon we call superconductivity. When a material enters this superconducting state, it doesn't merely reduce its resistance to negligible levels. It achieves perfect zero resistance, which means that once you initiate an electric current through a superconducting loop, that current will continue circling indefinitely without any external power source, potentially for thousands or even millions of years. The strange part is that despite decades of intensive research and thousands of scientific papers dedicated to understanding this behavior, we still cannot fully explain exactly how or why superconductivity actually works at the most fundamental level. We have developed mathematical models, particularly the Baryon-Kuiper-Schrieffer theory from 1957, which describes electron pairing and energy gap formation in ways that successfully predict many observable properties. Yet these theories remain incomplete and somewhat abstract, failing to provide complete mechanistic clarity about the underlying quantum processes. The mechanism seems to involve electrons forming Kuiper pairs, where two electrons with opposite spins and momenta bind together through phonon interactions, creating a correlated quantum state that can move through the crystal lattice without scattering. But the precise nature of this binding and why it produces zero resistance remains philosophically elusive and conceptually puzzling. When we measure the movement of continents across the Earth's surface, we encounter a peculiar inconsistency that challenges our understanding of planetary dynamics and geological timescales. The continents drift at speeds measured in centimeters per year, a rate so gradual that human perception cannot detect it during a lifetime. Yet when we examine the historical record of plate movements and magnetic reversals in oceanic crust, we find evidence suggesting these speeds have varied dramatically throughout Earth's history. What troubles geologists is not merely that the continents move, but rather that we cannot definitively explain why the rate of continental drift has changed so significantly across different geological epochs, and more perplexing still, why certain continents appear to accelerate and decelerate in ways that current models of mantle convection and plate mechanics struggle to adequately account for. The mechanism we typically invoke involves the movement of hot material rising from deep within the Earth's mantle, driving the separation of continental plates at mid-ocean ridges and pushing landmasses across the globe. Yet this explanation becomes vague and uncertain when we attempt to predict future movements or reconcile past speeds with present observations. We have normalized this mystery by accepting it as a solved problem, assuming that because we have named the process and developed mathematical models to describe it, we have achieved genuine understanding, when in fact the underlying physics of what truly drives these continental motors remains incompletely understood, and the causes of dramatic speed variations remain largely speculative. Deep beneath the ocean's surface, in the vast and lightless depths where pressure would crush most living things, whales produce some of the most complex and haunting vocalizations in the natural world. And yet these songs are not static monuments to evolutionary design, but rather constantly shifting, evolving patterns that change year after year in ways that science still cannot fully explain or predict. Humpback whales, in particular, have been observed fundamentally altering their songs on an annual basis, with populations sharing similar melodies that transform collectively as though governed by some invisible underwater convention, and researchers have documented these changes occurring across entire ocean basins simultaneously, with whales that have never directly encountered one another somehow adopting nearly identical modifications to their acoustic structures. The mechanism behind this phenomenon remains profoundly mysterious, because while we understand that whales learn their songs through cultural transmission, much like human music traditions passed between generations, the driving force that compels entire populations to abandon previously established patterns and embrace entirely new ones seems to operate beyond the parameters of survival, reproduction, or any other evolutionary pressure we have successfully identified. Scientists have proposed various theories ranging from acoustic adaptation to changing environmental conditions, to social conformity based on mating preferences, to the simple spreading of cultural innovation through populations that possess the cognitive capacity to appreciate novelty and artistic variation. Yet none of these explanations fully accounts for the synchronized, coordinated nature of these shifts or the apparent purposelessness of certain modifications that offer no discernible advantage. High above the Earth, observers have long noticed peculiar phenomena in cloud formations that refuse to align with our current understanding of atmospheric physics. Gaps that appear in cloud cover, where clouds should theoretically exist based on temperature, humidity, and pressure conditions, yet remain stubbornly absent despite all meteorological indicators suggesting otherwise. These gaps appear with remarkable consistency over certain geographic regions and during specific atmospheric conditions, creating almost geometric patterns of clear sky surrounded by dense cloud cover, as if an invisible hand has carved out sections of the sky with precision that nature rarely demonstrates. Scientists studying these formations have documented instances where satellite imagery shows cloud cover suddenly terminating at distinct boundaries, creating sharp lines rather than the gradual dissipation one would expect from the dispersive forces of wind and thermal dynamics. The mechanism behind this phenomenon appears to involve complex interactions between invisible atmospheric layers, temperature inversions that somehow suppress cloud nucleation in specific zones, and electromagnetic variations that influence how water vapor condenses in the atmosphere. Yet the precise triggering mechanism remains fundamentally unclear despite decades of atmospheric research and advanced modeling. What makes cloud formation gaps particularly unsettling is how we have collectively accepted their existence without fully understanding them, incorporating them into weather prediction models and satellite analysis without ever explaining the underlying cause, treating them as quirks of nature rather than genuine mysteries that challenge our comprehension of basic atmospheric science. Deep within the Jovian system orbits a moon that should not exist in its current state, a celestial body that defies the fundamental laws of planetary cooling and energy dissipation that we understand to govern all celestial mechanics. Io, Jupiter's innermost large moon, presents a puzzle so profound that scientists have spent decades attempting to reconcile what we observe with what our models predict should be possible. The mystery centers on an almost incomprehensible fact. Io is the most volcanically active body in our entire solar system, hosting hundreds of active volcanoes that continuously erupt with molten material and sulfurous compounds, yet based on its size and distance from the Sun, this moon should have cooled completely billions of years ago. The surface temperature near volcanic vents reaches thousands of degrees, and the sheer volume of heat being radiated into space is staggering, yet Io continues this apocalyptic volcanic cycle without apparent exhaustion. Scientists have proposed that tidal heating from Jupiter's immense gravitational field, combined with orbital resonances created by nearby moons, continuously flexes and squeezes Io's interior, generating friction that melts the subsurface rock and maintains the volcanic activity. Yet the deeper we examine this mechanism, the more questions emerge about whether our calculations of tidal heating are truly sufficient to explain the observed volcanic output, whether our models of internal heat distribution are complete, and whether Io represents an extreme case of a phenomenon we understand only partially. The persistence of Io's volcanic rage stands as a reminder that even in our own solar system, orbiting one of the most extensively studied planets, we encounter phenomena that our best physics cannot fully explain, and we continue observing this infernal world with growing fascination and uncertainty. In the microscopic world that exists beneath our perception, there exists a creature so impossibly resilient that it seems to violate the fundamental rules of biology itself. A being known as the tardigrade or water bear, an organism measuring less than a millimeter in length, yet capable of surviving conditions that would obliterate virtually every other form of life on Earth. These creatures can endure temperatures approaching absolute zero, exposure to boiling water, pressure equivalent to the deepest ocean trenches, and even the harsh radiation and vacuum of outer space itself, all while maintaining the basic functions necessary for survival, a capability so profound that it forces us to reconsider what we believe about the limits of biological existence. The mechanism behind this extraordinary resilience appears to involve a state called cryptobiosis, wherein the tardigrade enters a suspended animation of sorts, reducing its metabolic processes to nearly imperceptible levels while simultaneously producing specialized proteins and compounds that stabilize its cellular structures and protect its DNA from damage that would normally be irreversible. Yet despite decades of intensive scientific research, we still cannot fully explain why evolution equipped this humble creature with such seemingly excessive protective measures, or how the molecular machinery underlying cryptobiosis actually functions at the most fundamental level, as if the tardigrade possesses biological engineering far beyond what our current understanding of genetics and cellular chemistry can adequately describe. We have documented these creatures surviving for years in a state of complete dormancy, their bodies essentially frozen in time, yet upon rehydration they simply resume their normal existence as though no time had passed at all, suggesting mechanisms of cellular memory and molecular preservation that we continue to observe but struggle to comprehend. Consider for a moment the profound mystery that sits at the foundation of our planet's habitability, a question so fundamental that it reshapes our understanding of how Earth came to possess the vast oceans that define our world. Nearly all life as we know it depends on water, yet the origin of Earth's water remains one of science's most perplexing unsolved puzzles, one that astronomers and geochemists have grappled with for decades without reaching consensus. Our planet formed approximately 4.5 billion years ago within the solar nebula, a swirling disk of dust and gas surrounding the young sun, and during this violent period of planetary assembly, the early Earth should have been far too hot to retain volatile compounds like water. The temperatures near Earth's orbit would have vaporized any water molecules, yet somehow our planet accumulated enough water to fill oceans covering more than 70% of its surface today. Scientists have proposed multiple competing theories, each with significant evidence, yet none entirely satisfactory. One dominant hypothesis suggests that water arrived via carbonaceous chondrite meteorites and comets colliding with the early Earth during the late heavy bombardment, delivering their precious cargo of frozen water to our barren world. Another theory proposes that water was synthesized through chemical reactions involving hydrogen and oxygen-bearing minerals already present within Earth's primordial material. Yet isotopic evidence from water trapped in ancient rocks tells conflicting stories, with some samples suggesting extraterrestrial origins while others indicate terrestrial sources, creating a paradox that refuses resolution. What makes this mystery particularly unsettling is that we orbit within the habitable zone, we depend entirely on this water's presence, and yet we cannot definitively explain how it arrived or formed. We have all heard the claim that no two snowflakes are exactly alike, a statement so universally accepted that it has become woven into the fabric of our cultural understanding of winter's delicate geometry. Yet the scientific proof of this assertion remains fundamentally elusive and perhaps impossible to establish with absolute certainty. When we examine the physical reality of snowflake formation, we encounter a process driven by water molecules crystallizing around microscopic particles of dust or pollen in clouds, with each flake's structure determined by temperature, humidity, and atmospheric pressure at countless points along its descent to Earth. The mathematical probability that two snowflakes would develop identically, given the astronomical number of possible molecular arrangements and the infinite variables influencing their growth, is indeed extraordinarily small, yet this is not the same as proof that every snowflake that has ever fallen is fundamentally unique. The statement itself rests on a peculiar logical foundation. We cannot examine every snowflake ever created, we cannot preserve them perfectly to compare across time, and we certainly cannot prove the negative claim that somewhere in the world's history of precipitation, two flakes with identical atomic structures have never formed. What persists instead is a beautiful metaphor that we have mistaken for scientific fact, a poetic observation that captures something true about complexity and probability while simultaneously resisting rigorous verification. The claim has become so deeply embedded in popular science education that questioning it feels almost sacrilegious, as though we are diminishing something profound about nature's artistry. Yet the persistence of this unproven assertion reveals how readily we accept statements about the natural world based on intuitive probability rather than empirical evidence. For centuries, humans have observed pigeons released from unfamiliar locations hundreds of miles away returning to their home lofts with an accuracy that defies intuitive explanation. Yet the precise mechanisms underlying this navigational feat remain one of science's most persistent enigmas. A pigeon transported in a closed container to a destination it has never visited, where visual landmarks are entirely foreign and the sensory environment offers no obvious reference points, will nonetheless orient itself correctly and navigate homeward through a route it could not possibly have memorized, arriving at its destination with remarkable consistency across countless documented trials. This phenomenon is not merely a matter of luck or statistical anomaly, but rather a reproducible, reliable ability demonstrated by pigeons across different geographical regions, different seasons, and different experimental conditions. Yet despite decades of rigorous scientific investigation, neuroscientists and biologists cannot definitively explain how the pigeon's brain accomplishes this feat. Researchers have proposed numerous theories ranging from sensitivity to the Earth's magnetic field through iron oxide crystals in the pigeon's beak and nasal tissues, to an ability to detect subtle variations in ultraviolet light patterns invisible to human perception, to an acute sensitivity to infrasound waves propagating through the atmosphere, to a learned map-based system built from gradual familiarization with landmarks acquired through flight experience, to olfactory cues and odor gradients that might create an invisible scent-based map surrounding the home location. In the Taylor Valley of Antarctica, there exists a waterfall that flows from beneath the surface of a massive glacier, and this waterfall is distinctly, unmistakably red, as if the ice itself were bleeding into the frozen landscape below, and it is called Blood Falls. The color comes from iron oxide dissolved in the water, which oxidizes when exposed to oxygen in the air, creating that haunting crimson hue that has puzzled and fascinated scientists for over a century. Beneath the glacier lies a subglacial lake that has been isolated from the atmosphere for roughly 15 million years, a closed system so completely separated from the rest of the world that it exists in a pocket of time almost untouched by the modern environment. The water that emerges from this hidden reservoir carries with it ancient dissolved salts and metals that have accumulated over incomprehensible spans of geological time, minerals that would never normally be visible in such concentrations in flowing water. What makes Blood Falls so scientifically perplexing is not merely its appearance, but the fundamental question of how life could possibly persist in such an environment, and yet evidence suggests that microbial ecosystems thrive in that subglacial liquid, surviving on chemical energy rather than sunlight, operating entirely independently of the surface world. The mystery deepens when we consider that this isolated lake should theoretically have frozen solid long ago, and yet it remains liquid beneath tons of glacial ice, a condition that challenges our conventional understanding of how thermal energy distributes in such extreme environments. Scientists have proposed that the pressure of the overlying ice, combined with geothermal heat from below, creates a greenhouse effect that maintains liquid water despite the surrounding frozen landscape. In the arid grasslands of southern Africa, particularly across Namibia and South Africa, there exists one of nature's most haunting visual phenomena: perfectly circular patches of barren earth that dot the landscape like geometric scars, ranging from small rings just a few meters in diameter to massive circles spanning 30 meters or more, each one an absolute void of vegetation surrounded by a vibrant ring of grass that seems to thrive in the presence of the dead zone at its center. These formations, known colloquially as fairy circles, have captivated scientists and locals alike for generations, inspiring folklore about dancing spirits and supernatural forces, while simultaneously resisting every rational explanation that modern botany and ecology have attempted to impose upon them. The circles themselves present a paradox that troubles the scientific mind. They appear with remarkable consistency across vast geographical areas, they persist for decades or even centuries, they are absent in some regions while densely clustered in others, and most puzzling of all, the grass immediately surrounding them grows with unusual vigor and density, as though the dead zone at the center somehow fertilizes its perimeter. Multiple competing theories have emerged to account for their existence, ranging from termite activity and underground fungal networks to soil toxicity from plant allelopathy, and even geometric self-organization principles derived from mathematical models. Yet none of these explanations fully account for the complete constellation of observations researchers have documented, leaving us with a phenomenon that appears almost deliberately designed to resist categorical understanding. Deep within the ash clouds that rise from erupting volcanoes, a phenomenon occurs that defies conventional understanding of electrical discharge in the atmosphere. A phenomenon so visually striking and scientifically perplexing that it has captured the attention of researchers for centuries without yielding clear answers about its fundamental mechanisms. When volcanoes expel massive quantities of pulverized rock, ash, and gases into the sky at tremendous velocities, The ash column itself becomes electrified in ways that seem to contradict what we know about how lightning forms in ordinary thunderstorms, producing brilliant bolts of electricity that tear through the volcanic plume with an intensity and frequency that appears disproportionate to the conventional triggers we understand. The prevailing theories suggest that friction between ash particles generates static electricity in much the same way that rubbing materials together creates charge, and that the sheer density of particulate matter in a volcanic column provides an unprecedented opportunity for charge separation and accumulation on an almost incomprehensible scale. Yet despite decades of observation and study, scientists remain uncertain about the precise mechanisms that govern how volcanic ash becomes so intensely charged, whether certain mineral compositions play a critical role, how rapidly the charge accumulates, and why volcanic lightning sometimes appears before the ash has even left the volcano's crater. Beneath the soil of North America, in tunnels that extend several feet underground, cicada nymphs spend years in patient darkness, their bodies attuned to a biological clock so precise that it defies easy explanation. What makes this phenomenon genuinely unsettling to contemplate is that these insects emerge from the Earth in synchronized waves following cycles of 13 or 17 years, numbers that are prime integers, mathematical entities that can only be divided by one and themselves. The cicadas of the genus Magicicada do not emerge after 12 years or 14 or 15, but rather adhere to these specific prime number intervals with such consistency that when they do breach the surface, sometimes in the same location where their ancestors emerged decades before, their numbers reach biblical proportions, occasionally exceeding 1 million individuals per acre in certain regions. The biological mechanism proposed by evolutionary biologists suggests that these prime number cycles may have evolved as a predator avoidance strategy, a hypothesis built on the reasoning that predators with shorter reproduction cycles would struggle to synchronize with prey that emerge unpredictably according to prime number intervals, thereby reducing the success of any predator population that might specialize in consuming these insects. Yet this explanation, while mathematically elegant, requires us to believe that evolutionary pressure somehow encoded an understanding of prime number mathematics into the genetic structure of insects, whose neural capacity seems incapable of any conscious mathematical reasoning whatsoever. Over Lake Maracaibo in Venezuela, near the mouth of the Catatumbo River, there exists one of the most persistently mysterious atmospheric phenomena on Earth, a place where lightning strikes with such extraordinary frequency and consistency that it has bewildered meteorologists and atmospheric scientists for centuries, generating an average of 280 lightning strikes per hour during peak seasons. With some reports suggesting that the sky above this relatively confined region experiences more electrical discharge than anywhere else on the planet, creating a nearly perpetual aurora of violent electrical energy that the local Yucpa people have observed and documented through oral tradition long before modern instruments arrived to measure and quantify what they already knew. The source of this phenomenon remains fundamentally enigmatic despite decades of intensive study. For while scientists have proposed numerous theories involving mineral deposits, methane emissions from the lake bed, topographical wind patterns that create specific atmospheric conditions, and unique convergences of warm and cold air masses funneling through the Andes Mountains and across the Lake Maracaibo Basin, no single explanation has achieved consensus or completely accounted for the sheer intensity and reliability of the lightning activity. The phenomenon operates with an almost mechanical regularity that seems to defy standard atmospheric physics, exhibiting patterns that suggest an organizing principle we do not yet comprehend, and yet the scientific community has grown somewhat accustomed to this mystery, treating Catatumbo as a natural wonder rather than an urgent puzzle demanding resolution. The tallest trees on Earth exist in Northern California, where coast redwoods pierce the sky at heights exceeding 380 feet, yet despite centuries of study, scientists still cannot definitively explain why trees stop growing at a particular height or what the true biological ceiling is for arboreal growth. We observe that trees have what appears to be a maximum height threshold, and we know this threshold varies by species and by environment, but the precise mechanisms that trigger the cessation of vertical growth remain frustratingly obscure and multifaceted. The leading hypothesis involves hydraulic limitation, the idea that water cannot be efficiently transported to the crown of extremely tall trees because gravity and friction in the xylem vessels create resistance that eventually becomes insurmountable, causing the uppermost leaves to experience chronic water stress and forcing the tree to stop investing energy in upward growth. Yet this explanation, while logical, cannot fully account for all observations, because some trees in optimal conditions with abundant water still refuse to grow beyond their species-typical height, suggesting that genetic programming or metabolic constraints also play governing roles that we do not fully comprehend. There exists also the mechanical stress hypothesis, proposing that trees have physical limits imposed by the structural engineering required to support increasingly massive wooden columns against wind, weather, and their own weight, a theory supported by the observation that the tallest trees tend to grow in sheltered valleys rather than exposed ridges. In the remote desert basin of Death Valley, specifically within a dry lake bed known as the racetrack playa, there exists a phenomenon that has puzzled geologists and casual observers for nearly a century. Large stones, some weighing as much as 700 pounds, appear to move across the perfectly flat ground of their own volition, leaving long trails of disturbed earth and dust behind them as evidence of their mysterious journeys. These rocks, which remain stationary for months or even years at a time, will suddenly shift position and travel distances ranging from mere feet to over 1,000 feet across the barren landscape, yet no one has ever witnessed the moment of movement itself. The trails they leave behind are consistent and directional, suggesting purposeful motion rather than random displacement, and the phenomenon occurs most frequently during winter months when the playa experiences its most unusual weather conditions. The rocks appear to select their own paths with no regard for size or weight, as both enormous boulders and smaller stones participate equally in this inexplicable wandering, creating a natural puzzle that has inspired countless theories and sparked genuine scientific intrigue about the forces at work in this desolate corner of California. The explanation that eventually emerged from careful observation and experimentation involved a delicate combination of environmental factors working in concert. During winter rains, water collects on the playa's surface, creating a thin sheet of ice that forms during cold nights, and when the morning sun arrives, this ice begins to melt while remaining slick and frictionless, allowing stones resting upon it to be pushed by gentle winds that normally would have no effect on stationary objects. In the remote skies above the Gulf of Carpentaria in northern Australia, a phenomenon emerges with such geometric precision and undeniable presence that pilots have reported encountering it for decades. Yet the complete mechanism behind its formation remains frustratingly elusive to atmospheric science. These are the morning glory clouds, vast undulating waves of air that roll across the dawn sky like invisible ocean swells made temporarily visible by moisture condensation, stretching for hundreds of kilometers and appearing with such regularity that local communities have organized expeditions specifically to observe and document them. The clouds form in a distinctive tubular or wave-like pattern, rising and falling with an almost musical rhythm, and they move with surprising speed across the landscape, sometimes traveling at speeds exceeding 60 kilometers per hour while maintaining their coherent structure for hours at a time. Meteorologists understand that morning glory clouds are associated with sea breeze collisions and gravity wave propagation through stable air layers. Yet the exact triggering mechanisms, the precise atmospheric conditions that guarantee their formation, and the reason they concentrate so predictably in this particular geographic region remain subjects of active scientific investigation and genuine uncertainty. The phenomenon occurs primarily during the cool season months, typically from September to November in the southern hemisphere, and their appearance seems to depend on an intricate combination of thermal contrasts, humidity gradients, wind shear patterns, and terrain-influenced air circulation that we can observe and measure, but cannot yet fully predict or completely explain. When a droplet of water touches a surface far hotter than its boiling point, something remarkable and counterintuitive occurs. The liquid does not immediately vaporize upon contact, but instead hovers above the surface on a cushion of its own steam, a phenomenon discovered in the 18th century by the German scientist Johann Gottlob Leidenfrost. Yet the practical applications of this effect remain frustratingly unclear and largely unexploited despite nearly 3 centuries of scientific observation. The Leidenfrost effect creates a temporary thermal insulation layer between liquid and heat source, allowing the droplet to skate across surfaces with almost frictionless movement, rolling and dancing in ways that defy our intuitive understanding of heat transfer. Yet we have still not developed comprehensive industrial applications that reliably harness this peculiar property at scale. The phenomenon should theoretically revolutionize cooking, industrial cooling, pharmaceutical manufacturing, and thermal management systems, since it demonstrates a natural mechanism for protecting liquids from extreme temperatures while simultaneously enabling unique transport properties. Yet current applications remain oddly limited and specialized. Scientists have theorized that the Leidenfrost effect could dramatically improve heat exchangers by preventing direct contact between coolant and hot surfaces, could revolutionize the handling of cryogenic liquids, could transform medical spray cooling systems, and could enable entirely new manufacturing processes that require precise thermal control. Yet these applications have remained largely theoretical or confined to laboratory demonstrations. Scattered across the world in places like Pennsylvania, Australia, and India, there exist peculiar stretches of road where the laws of physics appear to operate in reverse, where vehicles seem to roll uphill without any engine power, and where water flows against the pull of gravity itself. These locations, known as gravity hills or magnetic hills, have captivated observers for generations, drawing curious travelers who place their vehicles in neutral and watch, astonished, as they are seemingly pulled backward up an incline. The phenomenon feels so convincing, so undeniably real in the moment, that witnesses swear by what their eyes and the behavior of their automobiles tell them, yet the explanation lies not in any defiance of gravitational law, but rather in a profound betrayal of human perception. What actually occurs at these locations is a masterpiece of visual deception rooted in the deliberate arrangement of landscape features and the brain's desperate need to establish a coherent sense of orientation. The surrounding terrain, whether consisting of distant hills, trees, or the curvature of the road itself, creates a false horizon that contradicts the actual slope of the ground beneath the vehicle. Our minds, evolved over millennia to navigate three-dimensional space, rely heavily on contextual visual cues to determine what constitutes up and down, and when those cues conflict with the actual angle of the road, our brains defer to the apparent horizon rather than the genuine slope. A road that genuinely slopes downhill can appear to slope uphill if the background landscape suggests an orientation opposite to reality, causing observers to misinterpret the direction of gravitational pull. The vehicle rolls forward down the actual incline, but the observer's brain interprets this motion as backward and upward, creating an irreconcilable conflict between expectation and sensory input. Beneath the Arctic ice, in the coldest waters of the polar seas, a phenomenon occurs that seems to defy the fundamental laws of thermodynamics and fluid dynamics as we understand them. Scientists have observed the formation of brinicles, which are essentially frozen tubes of extremely salty water that descend from the sea ice above like icy stalactites, reaching downward through the ocean beneath them. These structures form when cold, highly saline water is expelled from forming sea ice and begins to sink through the surrounding water, but the precise mechanisms that allow them to maintain their tubular structure while descending through an ocean that should be warmer and more hospitable remain poorly understood despite decades of observation and theoretical consideration. The water inside these brinicles is far colder and saltier than the surrounding ocean water, and as this dense brine sinks and freezes the seawater around it, it creates an expanding corridor of death for organisms in its path. Yet the exact molecular and thermodynamic interactions that govern their formation, their stability, their rate of descent, and their ultimate dissolution remain contentious topics within oceanographic circles. Scientists have proposed various theories involving convective currents, the role of salt concentration gradients, the influence of temperature stratification in the water column, and the peculiar properties of supercooled water. Yet none of these explanations have achieved universal acceptance or fully accounted for all observed variations in brinicle behavior across different locations and seasons.